No! Oh, my entrance was ruined by the wire of my microphone getting caught. Okay, I have to fix that. Let me try that again. Hold on, I'll be right back. Oh, wait, it's going to happen again. Okay, here we go. Hello. Good afternoon. Welcome to the Coding Train, a weekly YouTube thing that happens on YouTube with me, Daniel Schiffman. I said it right this time, I think. I think I got it right this time. My name is Dan. I'm here on a Thursday instead of a Friday. Usually I like to be here on a Friday, but this week I had a conflict with tomorrow, so here I am today. And I'm going to do some stuff and code some stuff. Boy, I've got to get going here. Okay. Somebody in the chat is saying Coding Train on a Wednesday. I'm pretty sure today is Thursday. Let me do some math here. Carry the one. Thursday. Today's Thursday, May the 4th. Happy May the 4th day. May the 4th be with you and all of that stuff. So, okay, so what's happening right now? Looks like everything is working. Looks like I am live. I see a bunch of screens with my face on it, and I'm here. Okay, so I'm just going to jump right in. Let's see. Let me introduce. Let me try this again. Maybe it'd be better if I walk in. Yeah, let me try that. I'm workshopping this. I need to get some new starts. Hello, welcome to the Coding Train with me, Daniel Schiffman. Happy May the 4th, Star Wars Day. I am here every week, sometimes on a Friday, sometimes on a Thursday. It's some sort of time where I happen to be here did I already do this? I already did this. Oh boy, this is not going well. Do you think I should rehearse? Possibly rehearsing could help. It's also very hot in here. I don't know what I'm going to do about this. I'm like a little bit, I got to get some climate control going on. All right, so today what I'm going to do is I'm going to continue some topics in coding from my course, Nature of Code, Intelligence and Learning. This course is actually finished. This was the last week of the semester here at New York University. Next week is a week of thesis presentations. There actually will be a live stream for all the thesis presentations here in the ITP program. But let me show you that. It's not going to be on my YouTube channel, but let me open up this web browser here. And if you go to itp.nyu.edu/thesis. Here you can see there should be a couple things. There's a presentation schedule and project descriptions. I'm going to click on this. So this is the ITP thesis website. Let's look for one by topic. Algorithms, art, behavior, data viz, education. I don't know. Ooh, machine learning. Well, let's look at machine learning. Let's try that. Oh, I'm scared. We got 3 projects. And we can look at this one, Leon Eckert. Biometric intimacy. So if you wanted to catch Leon's thesis presentation about biometric intimacy, I could go back to itp.nyu.edu/thesis, and I could now go to presentation schedule. I could search for Leon, who's going to be at 4:48 p.m., that's Eastern Time, on Wednesday, next week, Wednesday, May 10th. So anyway, I encourage you guys to tune into this live stream. There's going to be about 100 thesis presentations from students here at ITP. I will be sitting in the audience watching every single one of them. And at some point there will be a link. Oh yeah, live streams. What happens if we click on this now? ITP thesis live stream. Is it going to live stream? It's not going to because there's nobody there. My master volume could be turned up a few notches. This happened to me the other day as well. Let's see what I can do about that. The thing is, I've got like a bunch of things teetering on the edge, and I've got to find 3. Let me see here. Turning up, turning up, turning up. How's that? My master volume a little bit better. Okay, so anyway, so tune in next week to this thesis live stream. I hope that I'll be able to do my own Coding Train episode next week, but it's going to be a very busy week. As you can see, this is happening all week. And then the week after, if you happen to be in New York City, you can actually physically come to ITP. Tuesday, May 16th, Wednesday, May 17th. The times are there, 721 Broadway. All the students will have their work on display. And one of the reasons why I mention this is you might recall that in the winter I produced a short video recapping some of the projects. I might do that again, but I was thinking, what if I actually just live stream from the show itself? And I've been working on thinking if I can get an external mic to go into a phone. I could use the YouTube app to live stream. I could, I'm playing around with this like gimbal camera stabilization thing, so I'm hoping to have an actual live stream from the show itself. So my volume is fine, thank you. I turned it up now, so hopefully that's better. Okay, so let's see. That was one announcement. Other things I will plug for you briefly is, don't forget, if you want to support the Processing Foundation, you can become a member. This reminds me, I want to do a kind of membership drive live episode at some point. So I'm glad I'm remembering that. So consider contributing to the Processing Foundation. If you're, it is a 501c3 organization, so it's tax deductible here in the United States. If you would like to support the work that I'm doing on this YouTube channel, you can go to patreon.com/codingtrain. I will send you some books or stickers depending on what level you support, and you will also get an invite to our Slack channel. I am looking at the Slack channel right now. I will read the most recent message. After killing my VM and freeing up more RAM, audio seems fine. See? What a wonderful chat message that I just read. Okay. And finally, another way that you can support this YouTube channel is you can get your Coding Train merchandise here at codingtrain.storeenvy.com. I am not wearing a Coding Train hoodie. I'm wearing an NYU Shanghai hoodie, but I put a little Coding Train sticker on it. So it's kind of like a Coding Train hoodie, but you could get your own zip-up hoodie right here. Okay, so I have one that just hasn't arrived yet. I was hoping to wear it. I'm also wearing I don't want to mess with this, my Rogue NASA t-shirt, which I'm very happy about. Okay, so I think that's all of my introductory stuff today. I am going to open up the web browser again, and I'm going to go to Nature of Code syllabus, and guess what? We are here. We are ready for week 3, classification and regression. So this is some material here that I would like to cover in today's live stream. So before I do that, I will take some questions. By the way, I think I need a better... So 2 things that I need to improve. Well, a lot of things I need to improve, but 2 things I would like to improve is, 1, having a way for people to submit questions. I do have this Rainbow Topics repository, which is just people post suggested ideas, and then I had like a question label, so I could kind of look. Let's see if there's any questions there. Yeah, there's some questions. Well, maybe we can answer one of these questions. I think these are most of these. Let's look at this. Hi Dan, I just finished watching your P5JS versus processing videos. Really cool, thanks. I've watched loads of your Coding Train videos. You have a really good, oh, thank you very much. Okay, and pick a, okay, code it in, okay. So this is really more like a video suggestion, less a question to sort of compare and contrast doing things using P5JS with the native JavaScript on its own. So I'm looking for a good way to collect user submitted questions, maybe upvoting. Maybe I could answer 1 or 2 of those at the beginning of every Coding Train episode. For right now, what I'm going to do is look into the YouTube chat, which I'm pointing over there because that's where I see it. I'm going to look in the Slack channel for Coding Train patrons, and I'm looking right over here, and I will see if I can answer any questions. And while I wait, we're going to listen to a little of Symphony No. 40 in G minor. Will I ever do tutorials on C#? Asks It already scrolled by. Um, Unlikely, anytime soon, I think. The languages of choice that I tend to use in my own tutorials are Java, and I do Java programming in processing, and then JavaScript, often using with the P5.js, often with the P5.js library, sometimes with Node and other JavaScript frameworks. I would like to get into a little bit of Python, and maybe do a few Learn Python tutorials, and then bring in some machine learning stuff with some Python code. That's in the future. How long will you stream? So it is about 4:15 right now. I hope to be finished at 6 p.m. So we've got an hour and 45 minutes. What is a binary tree? Oh wait, what is a binary tree and what can you use it for exactly? Okay, hey, guess what? I have a coding challenge binary tree. I would suggest actually just finding that video and watching it, because I spend a good 20 minutes discussing what a binary tree is. David in the Patreon group writes, "Hi Dan, I've been following your tutorials on making a Twitter bot. I'm having some issues where the load JSON breaks when I try to attach it to a button mouse pressed event inside setup. It works inside of preload. Any suggestions?" Okay, so this is a great question. I don't know if this is your issue, but it might be. So let's say I'm going to open up Atom Editor here, and I'm going to close some stuff, and I'm going to make a new file. I'm going to just call it scratch.js and just save this on the desktop. Okay, so David, let's say what I'm guessing you have is you have a function preload, and then you have like var data, and then you say data equals load JSON some data.json, some file, and then maybe somewhere else in your code you are using that data, var score equals data dot, elements dot, index 0 dot score, something like that. So there's some JSON that you're reading in, and then you're pulling some data out of it. Now, what I'm assuming that maybe you did, I'm going to read the question again. Button mouse press. So forget about the button just for a second, because this will be the same. Let's say you just had a global mouse pressed event. And what you were to do there is you were to take this code, which is in preload, and put it here, and then try to access the data here. This would not work. This would give you a major bug, and this is because JavaScript, in its way that it exists, is by nature, I was going to say the human nature of JavaScript, the JavaScript nature, the nature of JavaScript is to be asynchronous, meaning this line makes a request to go and get that file, and at some point the data will come back. But it's going to move on to the next line of code while it's waiting to retrieve that data. The data won't be ready here. If you were working in processing Java, if you're doing something in Python where everything is synchronous, meaning the data has to be loaded before it can go into the next line of code, then you would not have this problem. So what you need to do instead is actually not set the result of load JSON equal to something, but rather have a callback as a second argument here, got data, meaning when load JSON is finished, execute this function called got data. And there is where the stuff will come in, and I could say data equals stuff, and score equals. So I did some weird things, because why do I have this global variable, and then I set the global variable? But that's if I want to access it later. There's other different ways I could organize it, but ultimately, if you are using load JSON outside of preload, preload is a special P5 function to make the loading of external media and data synchronous, meaning setup doesn't actually happen until everything in preload has finished. And it's because of the way P5 is programmed underneath the hood. This is not native to how JavaScript tends to work with loading stuff. But if you're outside of preload, because you want to load when you push the mouse, you've got to do it this way. Okay, hopefully, I would have, Adam in the chat, by the way, I would have in the Patreon group saying that I'm reading messages without screening them. I think I read a few words ahead, so I would have stopped myself if anything was a problem. Okay, I'm looking in the, Mike Soderberg asks in the YouTube chat, would you try an ant colony algorithm sometime? This is great. So one of the things that I'm a little sad about right now, I'm a little sad, is that I really enjoy doing quick coding challenges that, one of my favorite ones that I did is just the phyllotaxis pattern. It was maybe a 15 or 20 minute video, involved a little math, a little color, make a beautiful sunflower shape. And I sort of miss doing these kind of quick simulation coding challenges to do a little algorithmic art or something. But I do have a commitment to get through this particular syllabus. And so that's what I'm going to do. And with that, I think I am going to begin starting this week's new material. And guess what? It's 15 minutes in, and I'm here to start. Here we go. Great. Okay, so what do I want to say to get started here? Do you like my mug? Coding Train mug? Okay. It's finished. I'm going to put it over here and switch to drinking some water and see what we're going here. Okay. So what I need to do is, all right, let's look at this. I'm going to review. Here's the thing. My plan was I'm teaching at ITP this course, and the week that I teach, I would then go and make videos that same week, but I never was able to keep to that. So I'm like, oh, we did this in class like a month ago or a month and a half ago. I don't remember any of this stuff. So let me see. Okay. But that's okay. Okay. Can you remember? Okay. Got it. All right. So, yeah. Oh, yeah, you know what? This is too soon. I'm starting too soon. I think we should read some random numbers. Okay, where did we last leave off? I really should keep track. I should use a bookmark or something. 30,953, 63,369, 5,445, 20,240, 35,362, 82,072. 29,280, 72,068, 94,845, and 97,004. Okay. Is this class for beginners? Asks Musette Murray in the chat. No. So that's the other thing that I am very torn about, which is that I've kind of waded into territory. One of my goals with this YouTube channel is to be as friendly and open and inclusive and accessible for everyone, and in particular beginners to coding, beginners to open source. But I've kind of waded into this territory of doing a lot of somewhat medium to advanced content that I barely understand myself. So I'm committed to doing this, so I'm going to do this, and I hope that later towards the end of the summer and next fall, I'm going to get back to my roots a bit. I might redo a lot of the Learn to Program from Scratch videos, not using Scratch, in JavaScript with P5.js. I have some ideas about that. Okay, will there be a live stream tomorrow? There will not be a live stream tomorrow. So this is the live stream for the week today. Okay, so what I need to do here is I'm going to open up Terminal, and I'm going to run a little local server. And we go back to the web browser. Going to have this stuff ready. And I'm going to be in week 3 here. So these are so one thing about what I'm going to do today, just to let you know, is I'm going to build a program that does a similarity score between two people based on movie ratings. But I have all this stuff already built. I made these examples. I'll reference this again. But I made these examples, and a lot of the content comes out of this book, Programming Collective Intelligence. So let me put that somewhere where I can reach it easily. By the way, if you're wondering why I disappear over here, this is a computer. It just has green on it, so at least it's not blocking what's on the screen when I'm standing over here. But this is where I will look at the Slack channel. Okay, so let me see. So I want to build some stuff, but I also have some of these examples made already. And, I know what I need to do. Let's do some data cleaning. And I'm going to do this not in the edited videos. So I need to go to my Google Drive. and log in as Coding Rainbow Live. Did you know that this channel used to have a different name? What's that password for this account? Maybe it's this? Nope. Nope. Oh my God. Really? Seriously? What? There we go. Okay. So I'm logged in here. I'm going to look at this survey that I sent out. So if somebody could post a link to the survey in the chat, then now is your kind of like last chance to fill out this survey. And it's asked you to rate some Star Wars movies. We've had 47 people fill it out. I am going to, I want to look at the responses. I want to create a new spreadsheet. Oh wait, I'm going to give it like about 30 seconds here. So what I want to do now is I want to take this spreadsheet and I want to turn it into a JSON file. And there's a variety of ways I could do this. I could write my own program. I think I did this in a previous coding challenge somewhere, but I'm probably just going to use an online tool that's like a CSV to JSON converter. But before I do that, I want to go through the results manually and remove any entries that have sort of like, oops, I got to do something about the fact that I keep getting this cable caught on me. Okay, I want to remove, so hold on. I'm also now going to switch to this view. So you can't see, oh look, now you can see the green paper. The reason I'm switching to this view is I have learned my lesson and I don't, about opening a document that anybody can contribute to behind me on a live stream. Because sometimes people put offensive language and things in it. So I'm going to do the data cleaning while I talk to you. Maybe I'll play some music in the background. How about the kitten song? Whoa, that's really loud. Somebody complained that I play this dot too often, so we'll play this one. Okay. All right, create a new spreadsheet. Create. Oh, you can't see what I'm looking at anymore, but you can see me. So I'm just looking here. I'm going to delete these entries that have no name. I'm doing some data cleaning live. Okay, delete this row. I'm looking at everybody's names. Yes, somebody has a name that I am going to change. All right, now I'm looking. Chewbacca, Numac, Kaiser Soze. These are all fine. These are all fine. These are all fine. There's some duplicate entries. We might as well, I want to delete duplicate entries. And here's one with no name, which I want to delete. Okay. Okay, I'm going to delete. Here's some with no ratings.
I feel just sort of like a nice,
And look at all you nice people. Nobody's put any. Here's another blank one with no name. Let's remove this. I'm just going to scan through this. Okay, I think we're good. This dot was the last entry was from this dot. So I think we're good. Okay, now I'm going to turn off accepting responses. And I am back. Here. Okay. So there was 113 responses. I've now turned off accepting responses. I can turn it back on later. And what I'm going to do is I'm going to export this. Okay, what do I have here? So with a Google form, I'm just using a Google form. People enter their name and then their rating for each one of these. And some people are missing ratings for certain movies. I think we can account for that in the code. But you know what? I kind of want to, I'm just going to fill that. I'm going to fill these in because I think it'll just make it easier with just some random numbers, some random ratings. I should have done this in advance, obviously. Wait, hold on. Let's make it so I can see all these on the screen. Oh my God, how many movies did I ask people to rate? Okay. I'm scrolling through. Did I miss anything? Looks like I got, here's a blank one. Sorry that I'm ruining people's ratings, but this is all just for, okay, oops. Okay. All right, I think everything's there. No blank ratings anymore. These are our ratings. I'm now going to do export. Where do I do export? Download as a CSV. Got it. I can close this. I will now accept responses again. So if anybody wants to use this data set later, it can have more data in it. I'm going to close this. And I'm going to look now at the CSV file. Where did it go? Where did I? Oh, I guess it's in like downloads or something. Okay, right here it is. Star Wars.csv. Let's put this on the desktop. Let's open this in Atom. Where's Atom? Okay, I'm opening this in Atom. Okay, here we go. So this looks good. You know what? Ugh. So I'm going to fix this right here. I want to have simpler headers. So timestamp, name, and 1. So that's episode. Oh no, that's episode 4, right? Episode. Okay. Episode 5. This is data cleaning 101. Episode 6. Episode 7. Now we're at, oh, no. Episode 1. Episode 2. This is very scientific. Episode 3. And then now we have episode 7. Now we have Rogue 1. Rogue 1. And now we have the holiday special holiday. Okay, so now I have my CSV, which has a timestamp, a name, and a set of ratings for each person. Okay, so I'm going to save this. And now what I'm going to do is I'm going to go to the internet, and I'm going to say CSV to JSON. So CSV to JSON converter, let's try using this random website. Let's choose a file, and I'm going to go to the desktop. And what I want is, convert CSV to JSON. Select my input, here. Choose a file, starwars.csv. And now let's just generate it. Download result. Interesting. So no, I don't like this. I need a header. Input options. First row is column names. Great. So let's do this again. Look at this. Perfect. I have a nice big array with each name and set of ratings. Great. So now I'm going to download the results. And let's take a look at this in Atom as well. And now I have, great. So this is a JSON file. It now has just an array. Each object has the name of the person who submitted and the ratings for all of the different Star Wars films. Okay. Nick in the chat asked, was ITP affected by yesterday's Google Docs hack? I don't know if ITP in particular was affected, but NYU certainly was. I got tons of emails of, oh, don't open this, don't open that. Yeah, that sort of thing. Okay. Okay, now what I'm going to do, we're getting somewhere. Scared myself by clapping. I am going to get set up to program something. So now what I need is, don't look at what I'm about to do. I'm going to download P5 for the 6th time. And I'm going to go in here, and grab, I'm going to turn the camera back on. I'm going to grab empty example. I'm going to put it on the desktop. I am going to then go to the desktop and rename empty example to, let's call it similarity score. Okay, and I'm going to open that in, actually, you know what we should do? I'll just call this session, what is it, session 3, and put similarity score in there. And then I'm going to open session 3 in the Atom editor. And I'm going to go back to terminal. What's all this stuff here? Oh my God. Why do I have 18 million terminal windows open? I would like to close all of them. I am closing my terminal windows song. I need some new music. I really do. Okay. What did I call it? Session 3. Okay. Let's go to another port. And now back to the browser. And I have these examples. And I have these examples. Awesome. And this can go away. This can go away. And I need this. Okay. Can you see this? Yes or no is my question. Okay, let's do this. Okay, so now, what is next? The next thing I need to do is turn on this other camera and watch this. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot, son, this dot. So what I'm going to do first is some sort of intro video for this week's session. And I'm going to talk about what machine learning is in a general sense, what some different algorithms for machine learning are, and I'm going to talk about the difference between classification and regression. And then I am going to show what some of the examples are, and then after that, I will start doing the coding challenge. Okay. So, any last questions, comments, concerns, complaints? Yeah. Whoa, did the stream start over? Weird. Okay, hold on. Okay, hold on a second. Am I here? Everyone can see me. I lost the YouTube chat. This computer may be disconnected from the internet briefly. Did it? Please try again later. Hold on. Sorry, everybody. I've got to get the YouTube chat back. So I'm going to see if I can do that. Okay. So maybe that just didn't happen for me. I saw somebody with a message saying chat broken. Okay. Okay, perfectly fine. Here we are. Okay. I was offline for a few seconds. Yes, strangely enough, the stream now says to me that I've only been streaming for 2 minutes. Look at it, which is clearly not true. Okay. Oh, there's some applause. It's coming from the room next door. Okay, how am I doing with my markers is a question. Here's a marker. Here's a marker. Let's see if this marker works. I'm going to use this part of the whiteboard that's by the door. Nope, this one's no good. Let's try this one. This one's good. Okay, great. Okay, so let's get started, everybody. Okay, 35 minutes. Okay. Do you guys hear that applause? Okay, I think I'm ready for this. My watch is beeping. Okay. Okay, here we go. Ah! Do you know why? Okay, here we go. Hello, welcome to session 3 of The Nature of Code, Intelligence and Learning. So this is one of my opening videos for these sessions. If you are watching this video as part of that playlist for the Intelligence and Learning course, you will see a lot of videos in front of you with a variety of demonstrations and different coding challenges. There will also be a video at the end where I come back and pose some ideas for an exercise or assignment that you could try. But what I want to do in this particular video is now is the time. This course is sort of started with this little warm-up of thinking about artificial intelligence and search algorithms and graph systems. And then we took this turn and thought about genetic algorithms and evolutionary systems. But you might be here because you heard about this term machine learning, maybe even heard about this term deep learning, and you want to get a sense of what does that mean? What are the possibilities with machine learning and deep learning? How do machine learning systems work? What are they for? What's the lingo for this sort of stuff? And now's the time to get into that. Now, session 3 here, I will not be using any neural network yet. So what I want to do in session 3 is just talk about what machine learning is, what its applications are. So something that I'm going to cover here is classification and regression. What do those terms mean? And what are some classic algorithms for performing classification and regression? And so I'm going to look at something called nearest neighbor similarity, K nearest neighbor, and I'm also going to look at something called linear regression. And so these will be some sort of classic algorithms that you can play around with and do stuff with. And then in session 4, we'll start looking at what a neural network is and see how we can use that as part of a machine learning system. Okay, are you with me? By the way, I barely know about any of this stuff. So if you're watching this for an expert, you probably want to find somebody else on YouTube. But I'm learning this stuff, trying it out, and hopefully you're going to come along and join me on the train, right? Oh, I forgot, we're on the train. On this ride on the train in the sky with me as your guide. Do sky and guide rhyme? I think they do. You'll see. I had a point to this, but I digress. Okay, so what is machine learning? So first of all, one thing that I might suggest for you if you want to watch some videos about somebody who really knows what they're talking about, I would suggest Andrew Ng's Coursera course. A lot of my knowledge and inspiration has come from that course. And Andrew Ng does a good job of giving a nice introduction to machine learning and 2 particular references. One is this definition, this quote from Arthur Samuels, who is a pioneer in the world of machine learning, defining machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. And so here's an interesting thing we can think about. When we looked at the A-star algorithm in session 1 for pathfinding, we were designing, us the programmer, writing an algorithm to specifically perform a task. The computer would follow those instructions and get to a result. There was an intelligence to that algorithm. There was this appearance of sort of the computer solving a problem and thinking about it, but ultimately we had written the instructions, the code for the computer to solve to arrive at an answer. So what if instead of us writing the instructions, we would just set up a framework for the computer to figure out what the instructions might be, what are the right parameters for some type of model to perform some sort of task. So this is the idea of machine learning, and I would encourage you to look at the work of Arthur Samuels. One of the things that he did was train a computer to learn to play checkers by just having it play itself over and over and over again thousands of times to be able to learn what a good strategy was. But ultimately, so one of the things that I want to talk about here is, so let me come over to the whiteboard here. I have this README that I'll link to in the description. You can read some of the definitions and information that's on that README. But what I want to look at is this model for this. I'm going to describe to you machine learning in this particular way. So there is some sort of input. That input is going to go into some sort of algorithm, some recipe. I think that's a nice way of thinking about it. Some machine learning recipe. And then out of that machine learning recipe, we are going to get an output. The input into the machine learning recipe is typically numeric. So you could think of it as, a classic example that's always given is, what if we want to build a machine learning system that can guess the price of a house based on some inputs? So maybe we might say something like, oh, the house has 3 bedrooms, and it has 2 bathrooms, and it has 1,000 square feet, and et cetera, et cetera. This is the input into the machine learning recipe, and the output might come, the house is, $1 million. Something like that. Nice house, apparently. Okay, so this is what so typically speaking, another way of thinking about machine learning is making sense of data. So I have some sort of data and I want to make sense of it, have some input and some output. So 2 kinds of output that you'll see in most machine learning algorithms are classification, timeout! No timeout, I can't spell. Where's my eraser? Here's my eraser. Time in. One kind of output is classification. Another kind of output is regression. So what you might not have realized here is this example that I gave to you where the parameters of a house, a data point, goes into the machine learning recipe and we get this price output. This is actually regression. Regression refers to predicting some sort of continuous numeric output. Whereas classification refers to taking an input and classifying it into a discrete set of labels. So here might be another scenario. I have an image of a cat. That is the input into the machine learning recipe, and the output is something like this. I'm getting, usually the output comes at numeric, so we have to sort of figure out what this could mean, but I'm speaking in kind of higher level terms here, so I'm just going to say the output is cat. I am labeling it, and maybe the only possible options are cat versus dog. So what that output actually is something like 0.9, 0.1. Like there's a 90% chance this is a cat, 10% chance it's a dog. So this is classification, attempting to assign a discrete label to something like an image. We could have done something with the house data using the classification. We could say, fancy house, summer house, winter house. We could classify into one of 2 categories. That's classification. Regression, getting a continuous numeric output. I'm going to pause for a second and think about what I'm doing in this particular video and where I want to go next. Let me see if there's anything in the chat that people are asking a question. Okay, what about clustering? Yeah, so I need to get to all this stuff. All right. Okay, let me have a little bit of water here. I'm looking in the chat. Okay. People are talking about how you can't get even a 1-bedroom flat in London for $1 million. New York City is just as bad. Okay. Okay. So how does this work? So number 1 is we've got to at some point start talking about what are some different recipes that could go in here. And I could name you a few. For example, K nearest neighbor. This is a particular algorithm that can work for both classification and regression. I could say something like support vector machine, or I could say artificial neural network. And then there are a variety of flavors, so to speak, of styles of artificial neural networks, convolutional neural network, recurrent neural network. So this is something I ultimately intend to spend a lot of time on. What is an artificial neural network? How does it work? And why is it effective to put it in here? But even with all of the amazing innovation that's happening in machine learning and deep learning right now, there's a lot that you can do without artificial neural networks. A lot of simple, fun exercises and things. So in this particular session 3, I'm going to look at other algorithms that are non-artificial neural network based that become the machine learning recipe, like K nearest neighbor. But let's take a moment here to talk about how overall this works. Because the thing is, this doesn't just happen magically. You can't just, the point of doing this is that at some day, we might want to put an unknown image in here and get a classification label for that image. But how can a machine learning recipe do that from nothing? And it can't. So one of the things I want to talk about here is how does this work? So before you can actually use machine learning to make predictions for unknown data, you need to train the system. So the training step involves, so there are several different strategies for how a machine learning system can learn in order to perform operations like this. One is called supervised learning. And supervised learning is the strategy that I'm going to use in just about everything that I do in this particular course from session 3 right now and on, although I will come back to some other techniques as well. Another kind of learning is unsupervised learning. And another kind of learning that I really love, my favorite kind of learning, is reinforcement learning. In fact, I have a whole book all about reinforcement learning that I'm reading right now. Okay, so what are these different, and there's something called semi-supervised learning, and there's little variations on this, but these are 3 core types of learning that can be applied to the machine learning process. Let's start with reinforcement learning for a second. Reinforcement learning is a kind of learning where an agent observes the environment and chooses an action. You can think of a mouse trying to get through a maze. The mouse looks around, there's a wall here, there's a wall here, there's a wall here. The mouse decides to go left, the mouse decides to go right. And then once the mouse makes that decision, the mouse receives a reward. And that could be a positive or negative reward. And as the mouse receives more positive rewards for certain kinds of actions, it does more of those actions over the long term and gets better and better at things. So that's reinforcement learning. I'm going to spend a whole session looking at this at some point, and we're going to see some techniques. I have an example that uses a kind of reinforcement style learning to train to autonomously play the game Flappy Bird. Okay, unsupervised learning is a kind of learning that's generally applied to data that you know nothing about. So, I have 100,000 songs. And I just want to kind of learn what patterns are there in the songs. So typically, unsupervised learning is applied to problems like clustering. So I have all this data and I want to kind of figure out how can this data be arranged in groups? Could I have and I don't know anything about it. Could an algorithm figure out, based on patterns in the data, how to group that data, how to cluster that data? So I don't know that this is something that I'm going to spend any time. It's not on my current trajectory / syllabus, but it is something that I would like to do at some point in the future. And there's actually some ideas for some stuff I want to do about that eventually. Okay, but here we're going to give a nice little star and a heart and a little smiley face and like a little rainbow for supervised learning, because this is what I'm going to use in most of my examples over the next several videos. The idea of supervised learning is I have training data. So number 1, I have training data. Number 2, I have test data. And number 3, I have the rest of the world universe of data. So maybe we could call this unknown. I can't spell. Unknown data. So how does this work? So first, what we do in supervised learning is we take this training data. We have a huge database of a spreadsheet of bedrooms, bathrooms, and square footage for houses with their actual price that they sold at. So we have a data set that has the parameters and some sort of target, often called a target. So this would be like the training data with the inputs and a target. The idea is the inputs go into the machine learning recipe, they come out the other side, and some sort of guess is made. Maybe the house actually sold for $1.5 million, but the guess was $1 million. So the machine learning recipe got it wrong. So we turn some knobs here and mess around with it to try to get it to have a better result that's towards what that error is. So we're going to talk a lot about this error and that sort of thing. We're going to come back to this many, many times. So we do this over and over again with lots and lots of training data, turning all the knobs, trying to get it to do a good job. Then what we do is we have test data. Now test data is just like the training data. It's data that has inputs with a known result that we should get. But we didn't actually use it while training because we have this issue. A machine learning recipe might perform really, really well with the training data, but not with actual other data. So to see how well it's working, we've actually got to give it data that we didn't use to train, and that's called the test data. So we would feed that, see how well it does, evaluate the performance and say like, you know what? It got all the test data right, it's ready, it's all grown up, our machine learning recipe is ready to go, and we send it out into the world to start interacting with unknown data. So this is really the process. This is supervised learning. It's saying, hey, I'm the teacher. This is the machine learning system. I'm going to teach the system with my known data, with known output. I'm going to test the data with separate known inputs and known outputs. And then it's going to be all grown up. It's going to graduate. I'm going to send it out into the world and yada, yada, yada. By the way, I plan on doing a lot of yada, yada, yada neural network stuff. Like we might get to and then you have to do this calculus thing, yada, yada. I think that's a good practice to yada, yada, yada machine learning as much as possible. Okay, so pause again for a second. Let's see, what have I missed? Where am I? Oh, you couldn't really see what I was writing over towards the edge, but that's fine. Where am I in time-wise? Anybody in Slack keeping track of about how long that was? Okay, I'm looking at the chat, not seeing anything. Okay, so what did I miss? I talked about classification and regression. I kind of talked about what supervised learning is. Did you guys learn anything? Was there anything new that anybody watching didn't know? I feel like I'm trying to be very beginner friendly in terms of this sort of thing. I disconnected from the, I lost the internet again for a brief second. So weird. And I lost the YouTube chat. So let me fix that. I can't check how long I've been streaming because it keeps cutting out. Okay. So hold on, everybody. I've got to get back to... The good news is, even if the stream crashes out and that sort of thing, I'm recording to disk. So I've lost a lot of people. I noticed there was 800 people at one point. No. Okay, so I've got the YouTube chat again. Okay, so here I come. And, okay. Okay, so what I'm going to do is, actually, you know what I'm going to do? Hold on, sorry everybody, I'm thinking about this. Examples, do I have a list of examples here? No, how come I don't have my, I guess I didn't do so good at, do I have it on the wiki for homework 2 maybe? Wait, that's homework. Homework 3. No, okay, that's all right, so that's fine. So, okay, so I'm just gonna, so that's a brief introduction to what machine learning is overall and what some of the sort of key aspects of how a machine learning system works. We're going to get into a lot more about the details here, and we're going to look at a variety of different kinds of recipes that can be put in here and how they work with different kinds of data, like which recipe do you want to work with images, which recipe would you want for working with text, for this kind of classification, for this kind of regression. But right now, I'm going to move on and start looking at nearest neighbor. What is this thing called nearest neighbor? How can I look at two different pieces of data? So let me. So I have a bunch of pre-made examples in some of the. If you follow along with the playlist, you're going to see a bunch of examples where I code stuff from scratch. But I won't be able to do. I'm not going to do a video for every single one of these examples. I mean, maybe I will someday. But for the first thing that I'm really going to start looking at is, and this is an example inspired by. Rebecca Feebrink, who has a wonderful course called, I think, Machine Learning for Musicians and Artists from the company Cadenze. I'll put a link to that in this video's description, where she uses a tool that she built called Wekinator to do classification and regression and a variety of other things. So she does a lot of stuff with gestural interfaces and musical output. So one of the things I want to look at, and I'm going to hit play here. Can you hear that? Hold on. I'm going to stop. Yeah, I think you can hear that. Sorry, hold on. I'm not sure. You might have to edit this. Okay, so hold on. Why does this keep going to sleep? Okay. Okay. So I'm going to hit play here. And what you're going to see is, as I move the mouse near a particular note, the note changes. C, D, E, F. And this is actually a classification. This is an example of classification. What I'm doing is I have two-dimensional data, a Cartesian coordinate system, and I want to classify every x, y point to a particular note. This is classification. So the nearest note is the note that I play. I can actually switch this example to perform regression, and this is an example now of regression. You can hear I make a prediction based on a weighted distance. So here, I essentially have an average of C and G. I'm hearing a little G. I'm at a frequency between G and C. And you can hear G, C, G, C. So these are the kind of examples that I want to build to get you started with understanding the algorithms and have some ideas for some creative possibilities that you can do. And then we're going to just keep going. So, okay, so stay tuned. There'll be a bunch of videos in this playlist where I go through a few different examples and scenarios. I'll come back with another video with some homework ideas, and hopefully you'll make some stuff and share it with me and live your life in this world/universe/place, and maybe give somebody a hug or say something nice to somebody, because those are good things to do too. Okay, see you in a future video. All right. Okay, so there we go. I think that's my course. Yeah. Yes, there is also a deep learning, a TensorFlow course on Cadenza. I actually haven't had a chance to really dig into that, which I would really like to. Okay. So now I am ready to do some actual coding. I think what I probably should do is erase this. Does anybody have any questions? Did I miss anything sort of important? I'm going to erase this. And what we're going to do is do similarity scores. Okay, so now am I set up? Okay, so let me go back to here. I'm going to go to here, similarity score, open up the console, then I'm going to go to Atom, and what I need is that data file, desktop, and Star Wars. Oh wait, no, downloads. Where was this? So what I want to do is copy this into session 3 similarity score. Then I want to rename it. I'm going to call it movies.json, movies, and it's here. Okay. One thing I just want to see here is sometimes P5 is a little bit finicky with loading loading data that's just a kind of a JSON array without being wrapped inside of an object. So let's just see what happens here for a second. Okay, it was fine with that. It's just a plain old array. I sort of feel like, oh look, we missed a holiday rating. That's fine. That'll be an interesting thing to discuss. Okay, I do think though, even though that worked, I do also want to change the JSON file to be an actual object. So I'm going to, there's a lot of data in here. I'm going to wrap the whole thing in an object. Go back up to the top, please. And I'm going to say something like movies, or no, critics. Right? And it's not really critics. What is it? People, users. Let's just call it users. And so now if I do this, object users is an array with 103. Okay, I like this better. Okay. So I guess I can leave this. I'm going to say no canvas. Okay. Okay. And I don't need draw. Okay. Switch cameras. Ah, crap. Sorry, everybody. Sorry, I do need a notification system. Sorry about that, everybody. Boy, I was doing that for quite a while. I'm so sorry. Okay. All right, so let me just show you what I did. I was just mucking around with this JSON file, and I wrapped it in a users. Okay, sorry about that, everybody. Okay. It would be good if, what I could do is, if I have the volume on this computer, is there a way for Slack, those of you in the patron group, to be able to make Slack play a sound without it just being the sound that it always plays? I don't know. Okay. All right, so let's go forward here, and let's do this. Okay. All right, I am ready for, I need to turn this camera back on. How's everybody doing, okay? Ready for this? Okay. It's my inspirational music. I gotta like figure out, okay, let's see. It's a lot of whistling. Oh my God, that's a really long train whistling sound. Okay, can I share the JSON? I don't know of an easy way to do that. People want to code along with me? Let me think about this. Yeah, this is what I'm going to do. I have some random Dropbox account on this computer. And so what I'll do is, what I'm going to do is go to the desktop into my, let me put session 3 here. Session 3. I'm going to take the movies.json and go into Dropbox. And then I'm going to do share, copy Dropbox link. And, oh, that's great. Wow. So hopefully somebody can freeze frame this and copy down this link. Sorry, I should have a better way of doing it. I could tweet it out. Let me tweet it via Coding Train, the Coding Train Twitter. Is that going to be noise for random people? Shorten it. Okay, shorten it. Good idea. Okay. Paste bin it. All sorts of options. Let me just use Bitly. Come on, people. Okay, so let me put it in here. I thought that Dropbox has its own link shortening. Okay, so there you go. I'm sure I could customize it if I logged into an account or something, but that should work. Okay, great. So you should have that JSON file. Hopefully somebody caught that. And here we are. Okay. Okay. Use the force. I don't have any. I need to use the force. It's a good idea. Okay. paste bin. Yeah, I could have used paste bin. That would have been good too. Okay. Somebody else make a paste bin thing and put it in the chat. It's very hard to read the chat. I'm doing my best. It's 5:10. I gotta get moving here. Okay. And here we go. Let's see. Okay. Ready, everybody? I'm like doing my hair, makeup, hair. Wouldn't it be great if just like people started wandering in, putting makeup and doing my hair on me? That would be great. I'm one person operation here. Okay, here we go. It's really loud. Let's try the whistle instead. Okay. Hello, welcome to another episode coding challenge of the Coding Train. And what I'm going to do, okay, stop whistling. That train whistles a lot. Okay, let me forget the whistle. Let me start over again. Hello, welcome to another episode of the Coding Train, and I'm going to do a coding challenge. And what I'm going to do in this coding challenge, in honor of May the 4th, Star Wars Day, is I am going to make a simple movie recommendation engine where what I have, I've collected a lot of ratings from the Coding Train community of all the different Star Wars films. You can see Alka's here. Ratings are 555, 2454 based on the episode number, Rogue One, and no rating for the holiday special. You know what though, I'm gonna, I think Alka, give me a rating. Alka, you're in the chat right now. Give me a rating for the holiday special. Let's see if there's any other nulls. Oh, there's a lot of nulls for the holiday special. You know what? We're going to leave those nulls in there. We're going to work around the nulls. That's going to be part of our challenge here to deal with the fact that some people don't have ratings for particular movies. Okay, so what am I going to do? The first thing that I want to do in order to build this movie recommendation system, and first I should mention a couple things. Number one is most of the code that I'm going to write, even though I'm going to write it from scratch, is essentially the same code that's in this book, Collective Intelligence. And it's a wonderful book. It's from, I think probably from like 8 years ago at this point. I think this is 2008 or 2009, but it's my knowledge is old. I'm still trying to get there. And so I highly recommend this for you. I read this book again about a month ago, and so I'm sure whatever ideas are in there are still in my head, and that's ultimately what I'm going to end up programming here. The book is in Python, by the way, so if you want to see a Python version, I'm going to build this all as an interactive example in the browser using JavaScript. So what is this a part of? So before I actually get to coding, this is part of a set of videos where the topic is really K nearest neighbor. But in this case, I'm going to not worry about the K right now, and I just want to think about nearest neighbor. What I want to be able to do is, Alka and let's find somebody else, and Hab, LWGQ, and Habalwa, Alka and Halbawuka have both rated movies. Are they similar? Do they rate movies in a similar way? Do they have similar tastes? How can we numerically establish whether people who are rating movies have similar tastes or not similar tastes? And that has to do with nearest neighbor. That has to do with this idea of a similarity score. Now, there are a lot of different ways you can calculate a similarity score, and the kind of similarity score I'm going to use in this video is one of the easiest, simplest ones called Euclidean distance. Euclid being the mathematician who invented a lot of geometry stuff. And so Euclidean distance meaning actually just the sort of distance in space between these two people. Now, what does that even mean? These are people rating movies. They don't live, what space do they live in? How does that mean that they're far apart? Now, if I said to you, what's the distance between this little dot and this little star? Well, we could pull out a ruler and actually measure that distance in inches, in centimeters, in pixels. This would be Euclidean distance, the actual length between these two things, Euclidean distance on a two-dimensional plane. So with x, y values, it's sort of easy to think about distance. The same thing goes for x, y, z values. In fact, in this room, I could have this hand here and this hand here, and how far away they are, I could measure. That's the Euclidean distance. But let me ask you something. What if you thought about color for a second? Color is R, G, and B. At least digital color has a red, green, and blue value. So what if I have two red, green, and blue values? I have color 1 and I have color 2, which might be R2. Hey, R2D2. Can I please just have a red? What's a color that starts with D? I'm sure I'm going to get a million comments with interesting colors that starts with D. Oh, I wrote it. R2, G2, B2. Right? I could have R1, G1, B1. I can't even do it anymore. Point is, I could have two colors, and I could actually think of the distance between those two colors in the same way that I might calculate the distance between two x, y, z points. After all, it's 3 values. And in fact, if I have 4 values or 5 values, I can use the same formula that I would use to calculate the distance between 2 points in xy space, between 2 points in 5, 7, 10-dimensional space. It's very hard for us to imagine in our heads what that would look like, but the math is the same. What is that math? That math is actually based on the Pythagorean theorem. If this is point A and this is point B, and the sides, I probably should have not called these A's A and B, but if the sides of this triangle are A, B, and C, C is the distance between those 2 points. And A squared plus B squared equals C squared. So C equals the square root of A squared plus B squared. And in 3-dimensional space, A squared plus B squared plus F squared, 4 plus G squared. These are the X differences, the Y differences. So this is ultimately what we're going to do. Now, at the end, I'll show you why I'll talk about why there are some issues with Euclidean distance and other ways of calculating similarity. But ultimately, what I've now established is with these two, let's say both of these critics have rated, given a star rating to 5 movies. All I need to do is get a distance score, which is the square root of the rating of movie 1 minus of movie 1, Alka's movie 1 minus, so Alka's movie 1 minus H movie 1 squared plus Alka's movie 2 minus H movie 2 squared, et cetera, et cetera, et cetera, for all 5 of those movies. So this is where we're going to start. And eventually this is going to lead us to be able to get recommendations for a new person who comes in and maybe hasn't rated one of these movies to how can we guess whether they like it or not. Okay, coming back over here, let's start to write some code now. So the first thing that I need to do is I need to load all of this data. So I'm going to go into sketch.js. Oh, look, I already did it. Well, lucky me. I actually wrote some code before I started. So let's close some of this stuff here. So let's take a look and make sure that this data is actually loading into our sketch. I'm going to go to the browser and I'm going to go and open this up. Similarity score. It's not. What happened here? Why do I have this error here? Save. There we go. I don't know why that didn't work, but it's working now. And you can see, it loaded. There is an object that it loaded with a property called users, and that users is an array of 103 users. Each one of them has a set of ratings for all of these movies. Okay, great. So first thing that I want to do is I want to make something where the user can select 2 different critics by which to calculate a similarity score. So the way I'm going to do that is by 2 little drop-down menus. So what do I need to do? So the first thing I want to do is I want to say var users equals data.users. Now I want to loop through all of those users. And I'm just going to say console.log users index I dot, and what was their name is their name. By the way, because all this data came in via Google form, I'll put a link to that Google form, and that's what this timestamp is. This is the time that on May the 4th, this was submitted. Okay, so let's just make sure that works. And there we go. Ooh, look, Daniel Schiffman Jr. is somehow participating in this. There is no Daniel Schiffman Jr. Leo, okay, look at all these people. Okay, Z3RO, okay. So now, so what do I want to do? P5 has some functions for creating drop-down menus. And so I'm going to say person1 equals create select, and var person2 equals create select. And then I'm going to say, so create select should give me, whoa, I have an error. Oh, I don't have the DOM library. So one thing, I'm using the DOM library, so I need to make sure I have a reference to the DOM library. So let's try this again. So we can see there are two drop-down menus here, and this very silly page that has this unnecessary styling in it. Okay, oops. So let's make that a little bigger. So I can see I have two drop-down menus, but nobody in them yet. So what I want to do now is I want to say person1.option users index I.name, and I want to do that with person2 as well. So actually, I want to call this drop-down 1. I think it's going to be better to call this drop-down 1, and this be drop-down 2. So now we should see here, I've got these drop-down menus. So what I want to be able to do is just say, OK, I want to look at CodeLand, which was a wonderful conference, by the way, and EWOX, and calculate a similarity score. So I probably want a button, too. So let's create a button. I can actually just do that right in here using the DOM library as well. I can say create button submit, and there we go. And so I can do this. OK, so Alka and Unicorn. What's the similarity score? Submit. I want to get the similarity score. OK, so we have a little interactive system set up. Here we go. We're getting somewhere. OK, so button.mouse pressed and button.mouse pressed similarity. Let's call this Euclidean. Euclidean similarity. Boy, that's really hard to spell. Euclidean similarity. So that's a new function I need to write. Function Euclidean similarity. So now what I want to do is get who are the two people that I want to look up. Var person1 equals person1 equals dropdown 1.value. So the value function in P5 gives me the current selected value of the drop-down menu. And person2 is drop-down2.value. OK, now let's try console logging person1 and person2. Let's just make sure this works. Alka and Unicorn, and we can see Alka Unicorn there. OK, so we're getting somewhere. Now what I need to do is say, I need to write the algorithm that's going to, and what is this down here that I have open? Time out for a second. How do I get rid of this unnecessary extra menu down here? Command J brought it up by accident or something. OK. I realized that it's an array, so I don't have the, I need like a lookup table. I need to make an object. I guess I'm going to need to make an object. OK. I'm gonna keep going here. Mathieu, this is an edit point, clearly. OK. So I've just realized something. I have the two people that I want to compare, but I don't have an easy way. I have their names, but I don't have an easy way of accessing their data. And that's because my JSON file just came in as like a giant array. So I could loop through the whole array to find the ratings for each one of those people, but that's not going to be great. So what I want to actually do is, and I'm sure there's, I have to think about if there's a nicer way to do this, but what I want to do is I want to create a lookup table that is essentially called, and where did I say, I called this var users? But really what I want to do with this is I want this to be an empty object. Because I'm going to actually have this users variable become a lookup table for all the data associated with each user by their lookup by their name. So this loop, I'm just going to say data.users, data.users name, data.users name. So I'm going to forget about this variable as being this sort of shorter version of data.users and just use data.users there. And then what I'm going to do is I'm going to say users index. So you know what I would like to do is var name equals data dot users index I name, and I'm going to put the name as the drop-down option, and then say users name equals data dot users index I. So in other words, all of the stuff is in an array. That's how it came in this JSON file. I could have reorganized the JSON file to work in a different way, but I'm just going to build a lookup table here in the code. I might as well. So now I'm just going to show you the difference here. If I say console.log data and console.log users, I think you'll see in the console what I mean. So I'm going to hit refresh, and I'm going to pull this over here. Now look at this. This is data. Data is just a big array. 103 users, each one look up by its index. Order actually here doesn't matter at all. This next thing is actually every, oh, crap. I look through all of the names. I'm gonna remove this. Hold on. All of you watching the live stream can enjoy the profanity. I'm going to remove this entry here. I want to find it. What's a nice name? App Mango. Let's say Mango. This user has now been renamed to Mango. And I'm going to re-record that little spot there. I'm also going to take this opportunity to blow my nose. Okay, let's close this. And hit refresh. Okay. Oops, this computer went to sleep. Okay, so this is the original code. So up here is the original array, and you can see, look at that. It's just an ordered list where each critic is a lookup by its index. But this is useless to us. The order doesn't actually matter. So I've reworked the data, and now I have an object where each particular critic is actually listed by their name. So I can instantly see Corey's ratings are right here, look up by Corey. So now that I have that in my code, if I come back to the code, I don't need this console log anymore. I can now say I'm just going to show you console.log users index person 1. Console.log users index person 2. Now you might be asking yourself, huh? Wait, person 1 is a string, but you're using array syntax, users index person 1. JavaScript objects are collections of key value pairs, and I can access the key of an object. Like I could say users index Dan, or I could say users index Dan. These are 100%, well, these are identical, but a lot of times Dan might have a space in it, and so this is a completely invalid syntax, but this is valid syntax. So I have a video tutorial about this topic in particular called What is an Associative Array? I'm going to link to that in this video's description. So if this is new syntax for you, you could pause here and go watch that video and then come back. Okay, but I'm going to move on now. Okay, so let's just see if I have both ratings. And what I'm going to do is I'm going to, where am I? Too much stuff here. I'm going to now hit refresh, and I'm going to hit submit. And look at this, I have Alka and Alka, and now I'm going to go switch to Alka and Unicorn. I'm going to hit submit, and I have Alka and Unicorn's ratings. So we can see I've got those objects with the ratings. Now it's finally time. How long is this video going on? Are you still watching? If you are, thank you very much. I'm going to actually do the similarity score now. Okay, so what do I need to do? Okay, so first of all, I need to get all of the movies associated with this particular person. Now, this is a little bit tricky, actually, because once again, I haven't been too thoughtful about how I structured this data. So the data has all of these movies and these particular timestamps. So you know what I'm going to do? This is a little bit silly because I'm just going to have an extra thing. I'm going to hard code in the list of all the movies. Just to make this a little bit easier, I could certainly extrapolate this. I probably should do that. Let's extrapolate it. What I want to do is get rid of timestamp and name. So what I'm going to do, what I'm going to do, this is fine. Sorry, I thought about this stuff before I started. There's a lot of different ways I could approach this, so I'm thinking it through right now. But one thing I'm going to do is I'm going to say var titles, so the movie titles equals object.keys person1. So this is going to give me an array of all of the keys that are part of person1. What are those things? They are timestamp, name, and all of these. Now I want to ignore timestamp and name. So then what I'm going to do is I'm going to loop through all of the titles. And I'm going to say rating 1 equals, okay, so the actual title is titles index I. And then I'm going to say, you know what I should do? Let's remove from the array titles. Will this actually work? Can I say, let's think about this. What's the best way to, so if I say var titles equals A, B, C, titles.split, it's never going to, I could say titles.index of B, right? And then titles.splice 1, comma 1. And so that removed B. So what I'm going to do, this is a little bit awkward, is I'm going to say I equals titles index of name. And I'm going to just say titles.splice I, comma 1. So I just want to clean the data here a little bit. I don't want the name. I don't want the timestamp. J is titles index of timestamp. So that should work. So now I should be able to see console.log title. Let's take a look at this. Hit submit, and I got 0, 1. What? Okay, titles equals object.keys. What's wrong here? Hold on, I'm like looking at the chat, like who's noticing what I did wrong? There's a little edit point, Mathieu. Okay, what's going on here? Yeah, okay, so first of all, let me get rid of these console logs. Titles. Oops. 0, 1, 2, 3. Huh? Oh, the keys. I'm not, okay. Sorry, everybody. Oh boy. I made a silly error, which is important. Okay, I'm back. I made a silly error. This is not the full object. The whole reason I built that users table was so that I could grab the full object. So I don't want the keys associated with person1. Person1 is just the name. So this is really name1. This is name2. Now, person1, the whole thing, or I could say like ratings1 is users name1. Ratings2 is users name2. Then what I want to do is get all of the titles. Ratings1. So let's look at that. We can say, okay, they're all the titles, but it has timestamp and name in it. So now, if I console log titles again after removing them, we should see, there we go, the array with timestamp and name, and now here it is removed. And so now what I can do is I can get rid of these console logs. And now what I can actually do is say rating1 equals ratings for that, ratings1 for that title. Rating2 equals ratings2 for that title. So this is me looking at each and every one of those ratings one at a time. And now I want to look at the difference. The difference between how did user 1 rate episode 4 and how did user 2 rate episode 4. So now I'm going to say var difference equals rating 1 minus rating 2. This is, if I come back over here, the difference squared. And in the formula, I need to square that difference, sum all the squares of the difference, and take the square root. Again, lots of other formulas we could apply. The square root calculation is perhaps unnecessary here, and it's expensive, but I'm going to do it the standard traditional way. So what do I need to do? I need to add up the squares of all these differences. I'm going to say sum equals 0, sum of squares. And so now I'm going to say sum of squares plus equals difference times difference. And now I'm going to say square root of difference equals the square root of the sum of the squares. And actually, this is the distance. So this is now the distance. So what I'm going to do now is I'm going to say create P distance. So let's look at this, okay? Create P distance. So we're now going to see, let's see if we get something here. Now, if I do alka and alka, if everything works correctly, I should get a distance of 0. 0, right? Because two people, alka is identical to alka. Okay, now I'm going to switch to alka and unicorn, and I also got 0. I'm a little bit concerned here. Alka and Ewoks, 0. Okay, I don't like the way this is going. Let's see if I have an error. Aha, I can see it in the chat already. Look at this. Ratings 1 equals, no. Up here. Name 2. Very important that I actually get the ratings from the second user. So that was, Very important that I actually, very important that I actually get the ratings from the second user. If I get the ratings from name 1, it's going to be wrong. So now let's go back and say alka and alka have a similarity score of 0, and unicorn and alka have a similarity score of 6.32. Now here's the thing. If they're more similar, the number should actually be higher. And if they're really far apart, that number should be lower. I want to have a similarity score where the more similar two people are, the higher their score. So what I really want to do is make some adjustments to the formula. So one way to invert a value is to actually say similarity equals 1 divided by d, right? I want to invert the distance. If the distance is 10, I get 1 divided by 10, which is a bigger number than if the distance were 20, 1 divided by 20. But here's a problem. What if the distance was 0? So a nice way that I can fix that is just say 1 plus d. What this will actually give me is a number between 0 and 1. Because if the two people are identical, 1 divided by 1 plus 0 is 1 divided by 1, a similarity score of 1. And if d went to infinity, like the distance is as far away as possible, 1 divided by infinity approaches 0. So I have some number between 0 and 1. So we can now see alka and alka, and so now I want to create P. And let me actually change this to what I'm going to do is I'm going to I'm going to make a variable called result P. And I'm not really being thoughtful about how I'm designing this at all. I'm going to say result P equals create P with nothing in it. And then, so I'm just going to, instead of creating a new paragraph element each time, I'm just going to replace what is in that existing paragraph element with the new similarity score. So here we go. Alka and alka, similarity score of 1. Alka and unicorn, similarity score of 0.13. Alka and Ewoks, similarity score of 0.19. Let's scroll. Chewbacca. I saw a Chewbacca in here. Chewbacca and the Ewoks, a similarity score of 0.166666. Okay, so similarity score between two people. What have I missed? So one thing is there were some ratings that were null. So I gotta watch out for this. What am I getting if I have a null rating? So let's just say if rating 1 equals null, console.log null. So let's just check this. Did alka have? Yeah, so alka had one particular rating that was null. So what happens when I say null minus null? JavaScript has sort of worked itself out anyway, but what I really should do is check and make sure if either of these ratings is null or undefined. So I can't say not because it could be 0 and that would evaluate to false. I guess in this case, the only value I'm getting is null based on my data. So this is going to be fine. But I might have to be more thoughtful about error checking ultimately. But as long as rating 1 is null and rating 2 is not equal to null, I can go forward and continue to do this. So, so here we are. Now the only issue I might get is if somebody didn't rate anything, I'm ultimately going to get a similarity score of 1. But anyway, error checking aside, I could do a better job of that. At least I'm now checking to make sure there isn't a particular value of null. Okay, so here we go. Unicorn and this dot, and we have our similarity score. Okay, now I'm going to end this particular video here. And what I'm going to do, the whole point of this was I want to start thinking, oops. Okay, sorry, hold on. Okay. I wonder how long, this is probably very long. Okay. Okay, so we've come to the end of this particular video. I would encourage you to try getting this code, get your own data, make a different data set, see what you could do with this sort of idea of similarity scores. And here's an exercise for you, which I'm going to do in the next video. What if I wanted to take any user and just give me a list of the 5 most similar users? And this is the next step we need for something called k-nearest neighbor. Because what I want to do is start to evaluate to look at how can I find, based on all the data, what can I find that's similar to me? And so that's something I'm going to do in the next video, and that's going to lead us towards this idea of making a recommendation system for a new user who might not have rated all the movies. How can we then predict a rating for a movie that new user hasn't watched? So that's coming. The other thing I'll mention is something you might want to look into is the something called the Pearson correlation score. So one issue with Euclidean distance is that let's say the Ewok rates all the movies 4 and 5, 4 and 5, 4 and 5, 4 and 5 stars. Chewbacca rates all the movies 1 and 2, 1 and 2, 1 and 2 stars. Well, let's say that for every movie that the Ewok rates a 4, Chewbacca rates a 1, and for every movie that the Ewok rates a 5, Chewbacca rates a 2. Their distance score might be quite far apart, but their tastes are actually quite similar. So the Pearson correlation is a way of calculating a similarity score that kind of accounts for that difference in range. It has to do with fitting the data to a line and looking at the slope of that line. If I were to graph all of Chewbacca's scores and they looked kind of like this, and I were to graph all of the Ewok scores and they look like this, well, even though the Ewok scores are all much lower, it's the same shape as Chewbacca. So the Pearson correlation would be a very high similarity, whereas if Chewbacca's scores look like this, then they're going to be it's going to be a very low similarity. So I do have this built, and you can check this particular video's description for a link to an example that has the Pearson correlation score built into it. Maybe I'll come back and do that as a coding challenge, but it's a bit of an ancillary point to this particular video. Okay, maybe I'll see you in the next one. All right. Okay. I feel like this is like the most boring live stream ever. Am I right about that? It's already 5:45. I'm in the wrong camera. Here I am. Sorry, I don't know. Why I got to get something more exciting going here. Maybe people are actually learning something. Okay. Here we go. Okay, so next what I'm going to do, is I'm going to do the k-nearest neighbors. Okay. All right, let's think about this. Fire alarm was exciting. Yeah. Not false. Yeah, start drinking, boring, spice it up. Yeah, I don't know. I don't know what to do here. Let's, maybe it's Thursday. I should really be doing these things on Friday. What are you going to do? What are you going to do? Okay. All right, let's move on. Okay, so what I'm going to do now is I'm going to So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, 8, 7, 6. Well, this is like Perlin noise performance art. 9, 2,
Okay, I'm going to
6, 1, 9,
make some changes
4, 8,
here.
9, 2, 1, 3. I pick 9 a lot. 2, 3, 4, 3, 4, 5, 6, 5, 4. Well, this is like Perlin noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. Perlin noise that is. This is Perlin noise that is. Perlin noise.
Okay.
This is Perlin noise that is. Perlin noise. So this is Perlin noise that is.
I thought if I played some music and some motion, something. It might give me some energy to make this interesting. This is by F. Looper, available on SoundCloud.
But with Perlin noise, I might pick numbers like this.
Woo!
2, 3, 4,
Okay.
3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6.
Okay, I think we're ready.
5, 6, 7, 5, 6, 7, 5. Well, this is like Perlin noise performance art.
Okay, those were the times of yesteryear when I used to make entertaining videos. Okay, all right, here we go. Now, we are going to be in a new video, part 2 of this tutorial. Okay. Okay, here we go. Okay, part 2, here we are with, I made some changes. Now I have a web application that lists all the possible users in my system, and I can pick the Biscuit King, for example, and hit submit. Nothing happens yet, but what I want to do is hit submit, and I want to see the 5 most similar users to the Biscuit King. This is leading us towards this idea of k nearest neighbor, with k being 5. So k being 3, show me the 3 nearest, k being 10, show me the 10 nearest. So again, I'm not fully implementing the whole k nearest neighbor algorithm for a machine learning problem yet, but I'm just kind of looking at the pieces of it along the way of kind of doing some stuff. So, okay, so let's do this. Are you excited? Because the last video, if you watched the previous one, was so boring, I thought. But maybe you watched it, maybe you enjoyed it. This one's going to be probably pretty boring. But I have lots of energy now, because here we go. Okay, so all I did, by the way, is I changed it to just having one drop-down menu. And here's another thing. This was kind of terrible. And this, by the way, I should call this Euclidean distance. And I don't like what I did with this at all. What I should do is pass in 2 people, right? Because really what I should be saying is this general function. This should be a general function that can look at the Euclidean distance, between 2 people. And I'm going to, boy, I really don't like the way, I did so many terrible things in the last example that I don't like, but that's fine. I want this function, it was silly that I put this in the HTML right here. What I really want is for this function to return that similarity score. So I want to have a generic function that receives 2 names and returns that similarity score. So now what I have is when I press the mouse and I say find nearest neighbors. When I press the mouse, I want to find the nearest neighbors. So that's my function, find nearest neighbors. And to whom? Who are the nearest neighbors? Name is dropdown.value. So I want to find the nearest neighbors to name. Okay, so by goodness, what am I going to do here? So in order to find the 5 nearest neighbors, what I actually unfortunately need to do is calculate the similarity score for everybody and then sort that list by the most similar and take the top 5. Okay, so how are we going to do that? Well, luckily for us, we happen to have this nice array in data.users. That's the array of everything. So what I can do is I can say, let's go loop through data.users index, data.users.length. And what I want to say is I want to look at somebody else. Other equals data.users index I. And as long as other is not equal to name, like I don't want to check my similarity rating against myself. As long as other is not equal to name, I want to get my similarity score between Euclidean distance. We calculated this in the previous video. If you didn't watch that, link in the description below, et cetera, between myself, name, and other. So I want to look at all those similarity scores. Now, where am I going to put those similarity scores? Well, there's a variety of places I could put them, but why not just add it to that object? So data, index users, index I. No, I don't like this. So I think what I'm going to do is create a temporary list. So what I want to do is create a list called similarity scores is an array. And what I'm going to do is I am going to, for every single user, this will be interesting. Yeah, why not? What I'm going to do is I'm going to say similarity scores index I equals equals that similarity. So I'm going to make a little table called and let's look at all the similarity scores. Let's see if this works. Okay, here we go. So I'm going to run this and let's look at, okay, users is not defined, sketch.js line 45. Okay, because I put this function down here, and really what I should do is pass in the ratings, right? So what I probably should do is pass in the ratings, not just the name. So, I mean, there's so many different ways I could do this. This is the boring part. This is the boring part of this video. Can I make it more exciting somehow? I can have like a timpani going in the background. Can't even hear that. I can't hear that. Okay. But I didn't even do anything. So cut that out. Edit that out. Okay. Where am I here? I want the similarity score between ratings 1 is user's name, and ratings 2 is user's name. You know what? I don't like the timeout. Go back, edit. I don't want to do it this way. This is all for you live viewers out there. Plus, we can get rid of the stupid timpani, and it made no sense. Let me come back out here. Go back. Wait, what's going on here? Okay, I'm back to where I was. Okay, because okay, so what do I want to do? I don't have access to this users variable here. I'm just going to make it a global variable, which is not the best solution, but it will do for right now, so that I can have access to it there. Let's hit refresh, and cannot read the property for of undefined at sketch.js 60. So I have another bug here in line 60. Okay, hold on. What's going on here? Console.log name 1, name 2. So let's see, is this working at all? Name 1, Alka. So there is no name 2. Why did I not get a name 2? Other. Oh, dot name. This needs to be dot name. So this needs to be dot name. I want to look at the other's name, not the full object. And so now, where I'm seeing everything here, so I can take out some of these this console.log. So now let's do this. Come on. So there we go. That's my feeble attempt to make this more interesting. We can see this is an array of all of the similarity scores. Now notice there's no index 0 in this array because Alka happens to be user 0 and I am not. So what I should do here is I should do something like, I'm just going to do similarity scores equals -1. So by definition, if index I, so if it is yourself, I'm going to put the similarity score as -1. So I'm going to, that will, when I do the sorting later, it's going to ignore. So what I have here is an array of all of these values. And I can easily sort that array because then I have these values, I have this array of all the scores sorted. But that's not what I want. I want all of the names somehow sorted. But I have a separate array. Guess what? JavaScript array sorting to the rescue. So maybe you woke up this morning and thought, I hope I watch a video on YouTube about how to make a movie recommendation system. And then you watch the video and realize, bonus, I learned about sorting JavaScript arrays. So we're going to do this. So let me show you a little bit about this. Let's say I have an array and it knows what I want to type. It has some numbers in it. 52, 1, -7, 99, 5, 13. So I can actually say, array.sort. And what do I get? I get the array in sorted numerical order. Now what is the actual array? It actually changes that array. So it doesn't create a new array in sorted order. It actually changes this array that's in sorted order, and hopefully you can see that. Now here's the thing. If I have an array, and it's like some letters, C, B, A, Z, E, G, right? And now I have this array of all these letters. I can also say array.sort. And now I have it sorted in alphabetical order. JavaScript arrays can be sorted with the sort function if JavaScript happens to know how to sort them. Because what if I were to just put some generic objects or some other kind of data that doesn't have an obvious way of how to sort? How would it sort it? Well, JavaScript to the rescue, this sort function can actually take a callback. I can put a function inside of there, and the sole purpose of that function is to tell JavaScript how to compare two particular elements. So how am I going to do this? And I realize there's a flaw in the way that I wrote this, but everything's going to be fine. I know what to do. Trust me, I know what to do. It's going to be okay. Okay, so what is it that I want to sort? I actually want to sort data.users. I want to see that array, the array of all the users in sorted order where the most similar users are at the top of that array. So what I want to do is say, at the end of this, where I calculate all the similarity scores, I want to say data.users.sort, and I want to say compare similarity. Boy, I'm having the longest. So in other words, I want to write a function that compares the similarity scores between two. Now, what this callback, by definition, takes two elements that are in that array, A and B. So one thing I could do is just say, let's just look at this. Console.log A.name, B.name. Now, this is not going to do anything, but let's just run it, because it's just going to log stuff. Okay, let's run this. Submit. So, oops, I'm console logging too many things. I don't want to see this anymore. Let's do this again. Submit. So look at this. So it's definitely comparing Dak versus Leon, Ewok versus Leon, Daniel versus Leon, Blank versus Leon, Chewbacca. So this is a list of every user being compared to every other user in order to sort that array. However, I don't want to sort it by their names, right? If I wanted it to be in alphabetical order, I could do that very easily by comparing their names. I want to sort by the similarity scores. Oh, but how do I look up their similarity score by their name? No, I have no real easy way to do that, unfortunately. Luckily for us, I could not put these similarity scores in an array, but I could put them in an object where what I actually do is store it by their name. And in other words, I could just, at this point now, yeah, I could keep that as -1. So what I'm doing now is I'm going to store all of the scores in a lookup table that is organized by their name. So now what I want to do is I can say score 1 equals similarity scores for A, and score 2 equals similarity scores for B. So now let's console.log score 1 and score 2. Let's see what those look like. Undefined, undefined, undefined. Okay, what did A.name, B.name, right? I want to look it up by their name because the array that I'm sorting is the array of the full object. So I want to look it up by their name. So let's try that. And look at this. So we can plainly see we're comparing all these similarity scores, and now it's our job to say to JavaScript, to the sort function, this is how these numbers should relate to each other. If score 1 is higher than score 2, then user 1 should be before user 2 in the array. And the way that we do that is by saying, I can never remember this, so I always just do this through trial and error. But basically, it's up to me to return a +1 if I want A before B, a -1 if I want B before A, or a 0 if they're equal. Well, I don't actually have to do a +1 or a -1. What I can actually just return is I can return score 1 minus score 2. So I am giving a comparison score to these two similarity ratings to JavaScript so that it can sort those objects. Okay, so it's sorting the objects in data.users by their score in the similarity scores lookup table. Okay, let's now say console.log data.users. Let's take a look at this. Okay, here we go. Submit. So here's our array. Hold on a sec. I want to look at it. Boy, this is, why? Okay, I'm going to look at it. Now let's look. We should see a high similarity score for, nope, I think I did it wrong. Oh, I don't see the similarity scores here. I should put the This is very silly what I'm doing. So many things are wrong with what I'm doing. Hey, oh look, somebody in the chat is saying something interesting. I'm going to come back to this in a second. I recently published, Dimitar, an NPM package called Recommender. It covers some of the stuff explained here. Check it out at NPM. Does this guy always make live videos? Yes. Okay, I'm sure everyone's gone. This is probably my lowest rated live stream ever. So I realized, okay, I'm going to come back to this. I probably should give up and just put the similarity scores in this particular, or make the other array an array of objects with just name and similarity score. How did I do it in the example that I made? Nearest, did I say nearest horses? No. 520 viewers. Yes, I lost about 100 in the last hour. I'm not gaining. Someday, maybe if I I don't know what I would do to gain viewers. All the ideas that I would have would be terrible ideas. Okay, let's think about this before I come back. What I want to do is look at, you know what? By golly, I'm good. The topic is less exciting. You're right. Put the scores in the data objects. I know. The reason why I felt that was weird was because it's just sort of temporarily there, and I kind of liked having it be somewhere else. But I should just sort this. I could make this an array. It's okay. I'm coming back. Okay. I'm coming back to this. Okay. Everything's gonna be fine. Okay. So clearly this thing is sorted in the wrong order because alka is the first thing in the array, and alka has a similarity score of -1. I just realized I can't even see the similarity score. So one thing I could do, which you might do as an exercise, I could add as a property the actual similarity score here, but I'm going to do this in a little bit of a different way. So first of all, let me just say score 2 minus score 1. Let me invert that and run this again. And hopefully what we're going to see in the first spot in the array is Praetorian. So this is the user that's most similar to alka, but we can't really see this for sure. So how can I see this for sure? So what I actually want to do is I just want to display the top 5. So what I'm going to do here is I'm going to say for var I equals 0, I is less than I is less than 5. I want to look at the 5. So this is, I'm going to say var k equals 5. I want to look at the 5 nearest neighbors, and I'm going to say create div data.usersIndexi.name plus colon space plus similarity scores. So first of all, I just want to get their name. So let's put that in a separate variable. Name plus similarity scores by name. So let's see those come up. Here we go. And what I'm going to do is I'm going to make all of these divs. I'm going to put them in that result parent that I was using from the previous result paragraph that I was using from the previous example. Okay, so here we go. Let's look at the top 5 most similar users. Oh boy, isn't this exciting? To alka. So Praetorian with a, oh. Is it really a half an hour later? That's sad. Praetorian with a similarity score of 0.36. Leo with a similarity score of, I don't have other sounds, 0.333. Jeremy with a similarity score of 0.33, Barack with a similarity score, and Randy with a score. Randy there in the 5th spot with a score of 0.28. All right, so we could try this with any other user like Chewbacca, and we could see, oh, look at this. So I'm not clearing it, so let's, I think what I could do is, I might as well fix this while I'm here, is right when I'm about to find the nearest neighbors, I should just take, this is a silly way to do this, but is this going to actually work? Will this delete everything that's in result P just by giving it blank HTML? This might be a terrible idea. No, because those divs are still in there. So what I want to do is result divs is an array. This is a very silly thing that I'm doing, but I'm going to just put all those divs in an array so that at the beginning, what I can do is, and I'm sure I could dynamically access all of those by doing a select or something, but I'm just going to say result divs index I.remove, and then result divs is a new empty array. So that should, yeah. And interestingly enough, the sorting order, because these are all 3 are equal, I'm actually getting a different order each time, which is kind of interesting to realize. And now we can see we're getting similarity scores for any person. Kenneth, similar to this dot, Frost, Tryon, Stefan, and Keon. Okay, we've done it. Now we have the k nearest similar people to a given rater. Now, here's the thing. This is what I'm going to do in the next video before I leave here today. I'm going to make one more video. What if a new person comes onto the scene and rates a few movies, but hasn't seen one of the movies? How could I guess a new rating for the new user based on their similarity to their k nearest neighbors? And this is a regression problem. I want to predict a star rating, Like you could say it's classification because I could classify the stars into 0, 1, 2, 3, 4, or 5. But I might do like a 3.4. I might sort of calculate a numeric continuous score. But so that's what I'm going to do in the next video. I am going to predict a star rating of a new user who hasn't seen all of the Star Wars films. Are you going to be here to watch that video? I would say I hope so, but I fully understand if not. So I will see you maybe in the next video. Thanks for watching. Okay. Are the middle three always the same rated value? Or that's got to be cool. That's got to just be, no, I think there's just not that much data here. So we're just going to get a lot of similar, that was just a coincidence. By the way, I put my ratings in here. So let's see who, this should be in alphabetical order, but it's not. These are the people who are the most similar to me in their view of Star Wars films. Adam, Hari, Matthew, Unicorn, and Rockhart. Okay, how are we doing here so far, you guys? Everybody with me? Everybody okay here? You learning something? Are you enjoying yourself? I don't know. Someday I will do some more exciting stuff. Okay. So let's see here. What I'm going to do is session 3, similar score nearest neighbors, movie recommender. This is actually not a movie recommendation system. Well, I guess it is. Yeah, it is. It's not by movie, it's still by user. There's so many different ways you could do this. Mikulili in the chat asks, how can I get the schedule for these live videos? I'm really sorry about this. I don't do a good job of being consistent about time. I hope that in end of May and June, I'll have some weekly slots where I do the live stream at the same exact time because my schedule is much more open then. But you can get notifications by email that I sometimes send out. You can stay tuned to my Twitter. But the best way, at least to get a notification at least the day of, is to subscribe to my channel and then click the alarm bell, and it should give you notifications, YouTube notifications, the moment I go live and the moment I schedule a live stream. Okay. The fact that somebody just said, how can I get notifications for this with this like incredibly boring live stream thrills me to no end. Okay. What happened with my typo? You guys are telling me something in the Patreon chat about a typo, and did I get the hint? By the way, does anybody live in Newfoundland, Labrador? I think I'm going on a vacation there. If you do, can I get some tips from you, or anybody visited there? Tweet me at Schiffman. Okay. Okay. By the way, can somebody do some kind of data visualization on my gray hair? I think if you look back at my videos from several years ago, it wasn't so gray. All right. Here we go. Can we do this last piece? I think we can. So what I might do is prepare this in advance to, what I want to do is create, okay, what do I need to do? I need to have a, so I need to go back, movie recommender, and what I need to do is go to this code. So hold on, let me close these out. Go to here, and what I want is, okay, so I need to add a form. I need to add a form where I can rate the movies. Should I hard code this in there? No, I think I should probably dynamically extrapolate the form. Oh, I typed neighbor wrong. Where did I do that? How did I type it? Oh. Let's fix that. Okay, thank you. All right, so Okay, so what do I want to do? Do I want to include this in the edited version of the tutorial to spend the time to make the form, or do I just want to do the recommendation system? You know, why not? Why not spend the time? I'm going to do it anyway. Here we go. Okay. Still wrong? Still wrong? Neighbors. Is that how you spell neighbor? Is that right now? That's right, right? So sad. I'm glad this is. I'm glad you got neighbors. 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 Did I get it right? That's not gonna. Neighbor. 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 Neighbor, 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 the neighbor song. Never forget how to spell neighbor. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song, this dot, this dot, this dot. I feel like it's a little too vain just playing these songs over and over again. Okay. This is the end of. This is the last thing I'm going to do in today's live stream, which has been going on for a little over 2 hours. I am now going to do the movie rating thing. Okay. Please let there be a neighbor song. Come on, musicians of the world. Make me some music that I can play. It doesn't need to have my voice in it. Could you write your own song, sing it? I will play it. I would love to have some song submissions. That would make me so happy to have more music to play on these live streams. Okay, original music. Okay. Should have a different tune though, probably. Neighbor, neighbor. Won't you be my neighbor? I can't sing. Isn't it sad? My singing voice is terrible. Honestly, if I had a good singing voice, I would just be auditioning for musical theater to be on Broadway. But instead, I'm on YouTube making coding tutorials. So I guess that's good that I can't sing, because I would have never, if I could sing, that's what I would be. It would be so nice if I could sing. Paint, if I could paint, if I had any artistic talent in any way whatsoever, that's what I always wanted to do. But here I am, building a movie recommendation system in JavaScript, which is probably like the worst language ever to do this in, as I'm sure everybody in the chat has said over and over again. K nearest neighbor, K nearest neighbor, it's you and me. Are you within my K? It's the K nearest neighbor. There's 5 of K, and they're all together with me today. Hey. Yeah? Okay. Now, am I gaining viewers or losing viewers? Most likely losing them. Okay. Here we go. Here we are again. Whew. This is the 3rd video in this series about nearest neighbor and similarity scores, and we're finally going to figure out which Star Wars movie you should watch. So, how are we going to do that? What I need to do first is I need a form where a new user could enter this world. My name is user. That's my name, user. And I have only seen episodes 4, 5, and 6 of Star Wars. So I'm going to make some ratings, and that is going to predict which Star Wars movie I should watch, or how I might star rate other movies, something like that. Okay, so first, it's unfortunate for you that I didn't bother to do this before the video. Now you can fast forward a little bit if you don't want to bother with me building the form to get the stuff, but I'm going to do that now. So what I need to do, how am I going to do this? So instead of having a single drop down for all, I'm a new user. So what I need to do is just give me, I need those titles. I don't want to do this. Is there any way somebody else could just come here and do this part? I think that it might be time for me to be lazy about this. I'm going to be lazy about this. What I'm going to do is I'm just going to add 1, 2. Oh, these need to be double quotes. 3, 4, 5, 6. What did I call them? Rogue 1 and holiday. So what I'm doing here is I'm adding, and then I need a comma. I added to the JSON file just a list of all the titles. Obviously, I can extrapolate that from the data set in different ways, but this is just going to make my life so much easier right now. Let's do this. Let's be happy. Let's just make our lives easier. Why worry so much? Let's do it this way. Okay. Happy JSON file. We should all have easy, happy, easy JSON files. Okay, so now that I've done that, what I want to do is, where am I? In setup, I want to create, first I want to do is I want to get all the titles is now data.titles, and I want to loop through them. Titles.length, I++, and I want to say, I hate that I'm doing it this way. I'm going to do it this way though. It's going to be fine. I'm going to say var div equals create div. Yeah, this is going to be fine. Create div with the title. Let's look at what I got so far. All right, see, I got a div with all these titles. Okay, this is good. This is good. Var select equals create select. Select dot parent the div. So that's that drop down, and this should, I'm going to call this a drop down. That drop down should go in the div. Oh, look, there it is. This is the worst design form ever, but it's fine. And, there's so many better. Somebody's going to save me on the internet someday and make a really nice version of this with better data and better design. It's going to have it play a beautiful song about design and data. Okay, and then what I want to do is say var, star. What are the possible stars? You could have 0 stars, 1 star. I didn't give star is you could have 1 to 5 stars. So I'm going to say drop down dot option star. So now what's wrong? Oh, this needs to be parentheses. I'm giving all these stars, and this is not start, it's star, and that's not I, it's star. My brain is melting. Now look at this. So I could say I want to rate this movie this way, and this movie this way, and this movie this way, and this movie this way. Now I'm going to hit submit. And what I'm going to get, what I want to see is the movies that I didn't rate. I want to see what it would guess my rating should be. So I'm going to actually add an option where I'm going to say drop down option. I'll just call it not seen, I guess. So I can just rate the movies that I've seen and get a prediction for the other movies. That's where we are so far. Okay, we're good. We're good. Now we're ready to do something. So now I don't need any of this stuff from before, but I need to handle the mouse pressed. So what I want to do is I'm going to need this find nearest neighbors function. So when I press the mouse, what I want to do is what? Predict ratings. So I need a function that's predict ratings. Okay. And what am I going to do in this function? Okay, so first of all, I need to create a new user. New user is me. And then what I need to do is make a user object that has a rating. So how is the data organized originally? Each user object has the user's name and a lookup of the movie title and the rating. Okay, so now what I need to do is I need to say so what would be nice is if I put all of these drop downs somewhere in like a variable. So I'm going to say drop downs equals an array, and I'm going to, I could select them, but I'm going to say drop downs dot push drop down. So this is where I can now get, I can look at all of the drop downs, and I can say new user. Okay. Interesting. What do we need to do? I need to figure out how to pair. When I loop through each of these drop downs, I'm going to get this number, but I need to be able to pull out the actual value. So hold on, everybody. I'm thinking. So I need to actually pair it with the diff. So I'm going to just do something silly. What I'm going to do is I'm going to when I make these drop down, I'm going to say drop down dot title. I'm just going to titles index I. So any JavaScript object, the drop down is an HTML5, a P5 element. I could just attach another variable to it and put some data in it. So I'm going to do that. And I'm going to now say new, so as I go through the new user, so the title is drop downs index I dot title. The value, the rating, is drop downs index I dot value, the function. This is a function that returns the current selected value out of those options. So new user index title equals the rating. So let's just now console log that new user. Here we go. Let's take a look at this. So I am now going to say 3, 5, and I'm going to hit submit. And look, I now have a new user object that has all of these movie ratings and not seen. Now here's the thing. I think previously the way I had written this is I used null to ignore a similarity score. So what I should do here is, I think it might be useful, is to say if rating equals not seen, let's just, instead of using the string not seen, let's say rating equals null. So I'm just going to change that to be null in that user object. So let's just see if that works. So I'm just going to only rate 1, and we should see now, okay, so now I have null for all the other ratings. Perfect. So now what I could do is I could definitely see who are the most similar users to my particular rating here, because that we just did. So let's do that. So what I'm going to do is now I'm going to say, once I've done that, I want to say find nearest neighbors. But what did find nearest neighbors do before? Well, it got the user from a drop-down menu, but I don't want to do that anymore. Actually, what I want to do is I want to pass in a particular user. So what I want to do is I want to say find nearest neighbors for this particular user. I want to find the nearest neighbors for this particular user. So here, where did I get the user? I got the user from the name, Euclidean distance name. So the Euclidean distance function, it looks up, so many problems, so many things I have to fix, because I have to restructure the way I did this. This is the life of programming. It just seems like, oh, this won't be any big deal. I'm just going to add this one little feature. And then I've made all these weird, kind of not so great decisions earlier. So we gotta do better. Okay, so I'm just gonna have to live with myself, but I'm gonna try to make my life as easy and friendly and happy as possible. This function, Euclidean distance, should really receive 2 user objects. So what I'm gonna do is now have this receive ratings 1 and ratings 2. So these should be 2 user objects with all of the ratings. It's stripping out the name and timestamp thing, but that's fine. The titles I could actually just use. So now one thing I can do to simplify, since I have that movie titles thing, is I can get one thing I can get is I shouldn't scroll. Oh, so many functions in too many places. I'm scrolling all over the place. I can say when I look for the titles in Euclidean score. Please cut out all that scrolling, but thank you. Okay, when I look for the titles, just say var titles equals data dot titles. Okay, so that simplifies it. So I want to get the 2 user objects. So I'm going to come back up, and I'm going to get where do I? Just give me a second. Pause for a second. I'm looking at the chat here. I did not do any community variations today. James, did you have something for me? Because I didn't do that today. Okay, so where am I? What am I looking for? Okay. Okay, so what I want to do is back up to where I call Euclidean distance. This is where I call it. I call it between 2 names, but now the user is coming here. So I want to call it between user and not, and I don't have to worry about this anymore. This new user can't be the same. Aha. So I can actually, this is actually simplifying things. I can get rid of this. And other can actually be the full user object. And so now I want to say Euclidean distance between this new user and other. Similarity scores, et cetera, et cetera. Okay, so the rest should be fine. What if I must have missed something, right? But let's try this. So I'm going to rate a few movies. Just picking random numbers. I'm not even thinking about it. Hit submit. Okay. Sketch.js line 46, user is not defined. I should have known better to just try this. Line 46. Oh, this is right here. I'm passing in new user. I lost track of so many things here, and maybe you've lost me. Let's come back and say what we're doing. Predict ratings happens as soon as I press the mouse. I build a new user with a bunch of ratings based on the interface, and then I say find the nearest neighbors for that new user. And finding the nearest neighbors for that new user means go through and check all of the users in my database in that JSON file and compare the Euclidean distance, sort all of them, and show me the 5 nearest ones. And one thing I want to do is, now I'm going to just leave this like this. I'll fix this in a second. Okay, let's try this now. I'm going to rate a few random ones, hit submit, and ooh, okay. So this is good. I got a bunch of users. It looks like these are users in the coorder undefined. So something didn't work here. I'm going to have to debug this. Welcome to debugging. Okay, so let's try to figure out where this went wrong. So right here, let's look at similarity. So obviously, I assume what's happening to me is I'm getting a similarity score of undefined. So I'm just going to rate one movie. Oh, look at this. You know, the similarity scores worked. So the similarity scores worked, but somehow what I'm printing out here is undefined. Okay, so the similarity score, so the lookup is no longer by name because other is the full user, but I want the lookup to be by other.name. So let's just see if this works now. Great. So I'm exactly the same as all 3 of these people because all 3 of these people rated Star Wars Episode 1 with a 2. And we can see here's 4 people. Here's 4. Is this 5 people? All 3? 5 people. Okay, but now I could start to get some more interesting similarity scores by rating more movies. So here are the 5 most similar users to me. Here's something that is really bothering me. A nice little function, at least for like looking at stuff, is number format. So what I'm going to do is I'm going to say score equals number format, and I'm going to format the similarity score. And what number format does is I could say, give me this many leading decimals and this many trailing decimals. So I could say something like, 1, 2. And so if I do that, what I'm going to get now is this. So and here now what I'm doing, and this looks so horribly ugly, but design aside, at least I'm getting just the similarity scores with, and I can, with just 2 decimal places, even if they go on for much more. Okay, no, one of the things, you're getting so many of the same score because it's just a very small data set. This would work so much more, this would work so much better if rated 1,000 movies and then I had a huge database of other user ratings. Now, scale is also a problem. The algorithm would then run really slow, and there's ways around that I will get to at some point. I forgot The Force Awakens. Oh, yes. But no, but I didn't forget it in the data set, right? It's in movies.json. Yeah, I just forgot it in here. Okay, so let me add that in. Thank you. Let's include The Force Awakens here. And Force Awakens is back. There we go. Okay, thank you for that. Okay, we're finally ready. Now what I can do is guess a rating for a particular movie that I, the new user, has not seen. And after all, isn't that what we're here for? To figure this out? And maybe you fast forwarded all the way to this point in the video. And if you did, we're good. We're here. Okay. What do I need to do? I need to find the place where I need to find the place in the code where I create all those divs. And that happens at the end of find nearest neighbors. And what I actually want to do is instead of, I'm thinking about this. Pause. I don't need to display anything. If the end of this, the result of it is sorting, yeah, I think I'm just going to hack away at the code right here. There could be a better way to do this. I need a break for a second. I need a little water. It's 6:35. This has been a very long live stream. I'm just peeking at the chat. I'm feeling very hungry. I think I didn't eat a big enough lunch. Starting to feel a little woozy. Will this help? Oh, the camera went off. I knew that was going to happen. It's been about a half an hour. These are going to be some long videos that somebody someday might choose to watch. Everybody must watch these on like 2x speed, right? Okay. Okay. Loosen up. Here we go. Here we go. Okay. 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 Let's do this together. You and me. I feel your energy, your chakra. It's gonna go inside my vibrations somehow. This is all getting very weird. Let's stop talking about that. I need to refactor this because I don't want to look at the 5 nearest people. I want to use the 5 nearest people to compute some guesses for movies I haven't rated. So first of all, I need to keep track of the movies that I haven't rated. So let's do that. Where could I do that? Here is, so let's just do that here. So first, let's create an array called new titles. And what I'm going to do is var I equals 0, I equals data.titles. Do I already have titles here somewhere? I think I have just, this is a very silly way of doing this, but titles, you know what? I don't need to create a separate array. I need to go through all of the titles. I is less than, what I want to do is go through all the titles and find out, have I not seen that movie yet? So I'm going to say var title, if var title equals titles index I, if, am I a new user in here? Where am I? No, I'm user. If, and do I have access to titles? No, I need to say data.titles, data.titles. If user index title equals null, now is the time. Create div title. Create div title. So I want to do result p parent. Oh no, yeah. No. Div, this should be div parent result p. I had that wrong because I want to put the div inside that, but that's okay. I want to do this. create div title, result divs push, and then div.parent title. I just want to see the titles. We're going to get to this in a second. This step, boy, that took me a really long time. My brain is melting. This should just give me, on the HTML page, the movies that I want to have my predicted ratings for. Okay, ready? Here's a rating, submit. Okay, cannot read property append child of null. Div.parent, not title, result P. Try this again. Okay, so now what did the button go up here and holiday went down here? That is craziness. What is craziness? This is somehow getting parented. What have I done? What crazy, weird thing have I done? Oh, I know why. So I need to put that in a variable and parent it. Okay, everything's going to be okay. Can you hear my stomach grumbling? Okay, here we go. Great. So I should see a list of everything but episode 1 and episode 4. Perfect. So now I need to predict the star rating for those. We're getting so close. So now that I know, this is a title I need to get a prediction for. This is where I now want to look at the 5 nearest neighbors. Okay. Shh. It's going to be okay. So let's get rid of this div for a second. And right now, I am going to look at the 5 nearest neighbors. Okay. So I don't care about their name. That camera went off, but it doesn't actually matter. That'll be an endpoint. I don't care about their name, but I do care about their score. I don't care about number formatting it, because what I want to do is okay, how do I do this prediction? I want to basically take a weighted average of all of the neighbors. So let's think about this in using the whiteboard for a second. Okay. So for example, if we imagine just a 2-dimensional space, and if there were just 2 movies like episode 4 and episode 7, I could plot everybody's, this is somebody who rated episode 4 with 4 stars, but episode 7 with 1 star, right? Would be over here. So what I want to do is I'm a new user and I'm somewhere here. What I want to do is, and I've only rated, this is getting confusing. This is where, by the way, having a live actual set of people in the room with you would be really helpful, because I just lose myself like I'm talking into the void. But okay, so what I want to do is I want to look at the people who are nearest to me, maybe the 5 nearest ones, and make a prediction. But I want to weight. I don't have to do this. I could just take the average of all of these. But what I want to do here is I want to weight this person who's nearer to me. I want to weight the prediction that I have for I want to weight their movie rating more heavily than somebody who's a little bit further. So how am I going to do that? Well, first I could just do the average. Let's do that first. It'll be a little simpler. So what I want to do is I want to make a sum of all of the ratings. So what I want to do is, what's the title? This is the title that I want. So sum plus equals the user's index name, index title, right? Isn't that their rating, right? Because the ratings is users index that name. I don't need the similarity score right now if I'm just going to do an average without weighting it by similarity score. So I could say sum plus equals users, so I could everybody's leaving. I'm looking. I just need like a little break, and then I'm just gonna churn through this. I'm gonna come back. I want to just start over for a second, and and not, I'm going to come back to this. It's going to be great. Believe me. Ugh. Ugh. Blech. Okay. Okay, here we are. Where was I? Yeah. Okay, here we go. I know what I'm doing now. I've got, stay hydrated. Okay, here we go. People are leaving because it's 1 a.m. in the morning in Europe. Yeah. Maybe put some emojis in the chat that are like motivational emojis. That's going to help me. I don't know if that really helped. I think I might have pulled a muscle there. Okay. Okay, so first let's actually just take an average of the k nearest neighbors ratings over that particular title. So what do I want to do? Forget about the similarity score for a second. What am I doing here? So what I want to do is get all of the ratings. User title isn't right. Okay, so how do I do that? The ratings are from that user's, my variable naming is pretty poor here, and I need to do a better job with that. But users, remember, is the lookup table of all of the users. User right now is me. I should probably not call, I should really rename this stuff. And maybe I'll refactor this when I publish the code. Okay, I want to get the ratings from all of the users for one particular, so that's name. Okay? So these are all the ratings for one particular, now what I want to get is the actual rating is the ratings index the title, right? So first I need the user, the k nearest user. Where is name coming from? Wait a second. Users, okay, hold your horses. I went a little nuts here. Users index k. Forget about the name. I can get the I'm going to get the similarity score by the name. K is what I want. Come on, we can do this. I want to look at that the k nearest neighbors. It's sorted. I'm going to get the ratings for that particular user. I'm going to get the rating for this particular title. Then I'm going to add them all together. Sum plus equals that rating. Then what do? Sum divided equal by k. And now, here we go. I can make a nice little div. And what is that div going to have in it? It is going to have the title. Where am I looking? You're over there. It's going to have the title plus a colon plus sum. And I'm going to just say stars equals that sum divided by k. That's going to be the stars. And I'm also going to number format it so that it's with a 1 leading digit and 2 decimal places. Okay, here we go. Now this isn't good. There's a bunch of things I want to do to this to make this better and then talk about all sorts of things that I've missed. But I think we're somewhere. Bear with me. I don't like episode 1. I don't like episode 2. I don't like episode 2. I like episode 5, 4. Submit. Cannot read property V of undefined at find nearest neighbors. Okay, let's see if we can fix this. Sketch.js line 83. Oh, this isn't, ratings is, okay. Let's think about this. Users is the lookup table, data.users. See, I've done a lesson learned. Maybe what I'm going to do after this video is do a separate video where I just refactor this to make it with better variable names and make it more organized in a way that I could follow. I've done a terrible job. This is really a lesson in poor code management, but hopefully you're learning something by seeing me do it. What I wanted to look up, the array is actually data.users. Data is the stuff I loaded from JSON. So data.users is my array. Users was my lookup table. So This is what I want. So let's see how this goes. Oh my god, oh my god, oh my god. Hit submit, I can't hit submit. Oh no. I think we're in an infinite loop. Right? I think I've frozen the browser. Right? Hello? What's going on? Hello? I can't do anything. I can type here. So where do I have an infinite loop? Or something. Can I refresh the page? I've crashed everything. Users index I? No. K. Oh, I! Not K. I need some more sad sound effects. My brain is so toast right now. You're absolutely right. Ideal. Okay, so one thing I have to do is kill this and see if I can get it back. Oh no, it didn't. Oh, I'm in the wrong place. Sorry, everybody. We're going to edit this part out and try to get back to it. Something else is going wrong here. Yeah, it's still having this problem. What have I done? Okay. Oh, terrible, terrible, terrible error. Look at this. I'm not paying close attention, and I'm in a loop within a loop, and I used I twice, which is absolutely a disaster. So no wonder I had an infinite loop. Let's change this to J. Okay, I'm feeling slightly more confident now. Ooh. I really should stop doing this. I got these star ratings. So I really think that I should have, so I should really be seeing episode 5 or 6, and I'm really not going to like the holiday special. This pen, by the way, has been in the way all this time. Okay, so we're doing well. This is pretty good, and I really should quit while I'm ahead, even though I'm not very far ahead. I'm way behind. But we've now got a prediction engine. I would be nice to sort these. I'd probably want to sort these. I can leave that as an exercise for you. But I absolutely should do the weight. I should do a weighted sum. So let's at least add this. And I'm seeing it in the chat. I'm going to do it right now. Okay. And I really should add some emojis to this because I need some happiness and some smiles and some hearts in my chat. Okay. Here we go. Okay, so now what I want to do is let's use that similarity score. Score equals similarity scores. Okay, similarity scores index name, but what is the name? So the name is data users index j dot name. So remember the name. Again, I don't know that I love the way I've organized this. The similarity scores are in a separate lookup table than the original data. So the data, which I really probably should have put them in the original data. But anyway, the name is coming from the sorted array of users. The score then is coming from the similarity scores. And then the ratings is also in that original lookup table. So now the weighted sum. Okay, so a couple things I should do. I need the weighted sum, and then I need the similarity sum. And I'll try to explain this, I think, in a minute. So I need two different sums here. So what I need to do is add up the weighted sum equals the ratings times the similarity, the score. And I don't know, maybe I'll call this just sim for similarity. So this is the weighted sum. It's the rating time. Now remember, if they're really similar, the similarity score is 1. If they're not very similar, the similarity score is 0.1. The reason why I need this similarity sum is that this is to get the average. Like if I add up 5 things and divide by 5, I have an average. But I'm not adding up 5 things now. I'm adding up 5 things weighted by similarity. So what I actually want to do is the number of stars is the weighted sum, divided by the similarity sum. So this is actually going to give me the weighted average. Does this make sense to you? If it doesn't, ask in the comments. Maybe I can sort of answer this again another time or make another video. But now I have the weighted sum. Now the other thing here is it's very likely in a more elaborate system that the user is not going to have rated, every user is not going to have rated every other movie. So I'd need to do an error check to make sure, and I should do that here. So I should check as long as rating is not equal to null. That could be null, then I add this up. And this is going to work. So there could be 1,000 movies. It's only going to add up the ones that that particular user has rated. Okay, here we go. Okay, here we go. And I am now going to rate some movies. I'll stop using the sound effects. 4. No. I really don't like episode 1 or 2. 3 was kind of okay. These are all good. Oh, this is a good one. Come on, Empire Strikes Back, Return of the Jedi. I liked 7. Okay, here we go. So what will be my estimated star rating for Rogue One and the 1977, I think? That's not right. Whatever the Star Wars Holiday Special. The guess is I'm going to rate Rogue One at 3.96 stars and Holiday at 1.6 stars. We did it! Okay, I wish I could play some Star Wars sound effects, but I'll get a copyright problem. So this is now a recommendation engine. It has got a very limited data set. There's a lot of problems with this, but let's think about what are some things you could do with this going forward. First of all, you could think about a whole other context of what you might use this in. I mean, think about similarities and predictions of rate. It doesn't have to be, product ratings, movie ratings. You could think about any property associated with a person, a thing. Think about word counts. What if you look at all the emails sent from all of your friends, and you counted all the words in all of those emails? Essentially, those word counts are the equivalent of star ratings for each word. Can you find similarities between your friends? Can you predict? This is sort of laying the foundation of how you might do spam filtering, for example. So there's a lot of ways you could think about a data set that's full of key value pairs and how you might have a lot of data points and make predictions based on that. And that's what's happening here. That said, maybe you're interested in doing something really close to this, like a movie recommendation system, getting your own data set. Now, here's a challenge for you. I meant a lot of this code I should thank again. I'm building this based on after having read this collective intelligence book. I'll put a link to this book in this video's description. Something you might think about is, what might you think about? Movie Lens. So there is a website called Movie Lens, and Movie Lens has a giant data set with 20 million ratings. So you could actually build this exact same program with a large, massive data set. Now you're going to have a lot of issues all of a sudden with performance. And so how do you approach that? Now that's a topic for a whole other video, but that's kind of a challenge for you. And something that you'll notice here is I have to go through every single other user, because this is all, I'm looking up everything by user. But I could have some pre-computed lookup tables that kind of know something about how movies are similar based on user ratings and calculate these predictions based on movie similarities as well. So this is covered in this book. Maybe I'll come back and do another video on that. I didn't explain that very well, but this is user-based. You could do something that's item-based, and that's going to really improve speed. Maybe if you use a database and have some pre-computed lookup tables in certain ways, that's other ways you could approach it. Write in the comments ways that you think about how you might do this with a large data set. But even just redesigning, doing a better interaction, building a actual server-side program that saves stuff in a database, I would encourage you to go do something creative with this, something strange, something useless, something playful, and share it with me. So thank you for, if you're actually still watching, thank you so much for sticking through all 3 parts of this tutorial series, for building a little movie recommendation engine with me. I can't wait to hear what you think, what you make. Subscribe, like, all that sort of stuff, and I will see you in the okay. Hold on. What was your actual rating? Remove yourself from the data set and then see how close it is to your actual rating. Oh, interesting. Okay, there's a little challenge here. Let's try this. This video is not ending, Les. Okay, not ending yet. My words are jumbled. Okay, I'm going to go in here. I'm going to remove myself from the data set, Shiftman. So, oh, look at this. I could actually just 4 and 5. So it got my Rogue One rating pretty well, but I gave these different ratings. Cut this part out. I'll do this afterwards, not as part of the video. This is a great idea. Mathieu, edit this part where I started to go off on this, because this video is probably like 45 minutes long already, and it's 7 o'clock, I've got to go. Okay, but I'm going to try this in a second. So thanks for watching, and I'll see you in a future coding challenge video thing, etc. Goodbye. All right. Okay, let's try this. So if I can remember, I said 4, 5, 4, 1, 2, 2. So I gave some different ratings now. 4. Okay, so I think that's kind of similar. I didn't put 3. So let me remove myself. Take this out. I'm going to save it somewhere so we could see it. Then I am going to rerun the program. And I'm going to put my ratings in. 4, 5, 4, 1, 2, 2, 4. 4, 5, 4, 1, 2, 2. This is not right. These are in a different order. 4, 5, 4. 4, 5, 4, 1, 2, 2. And should I do 7 and 4? And here we go. 3.6 and 1.4. Here's the thing. This is probably not that much better than just taking an average of everybody. So the thing is, it's not going to really ever give me, I actually have not seen the holiday special. I think I watched some clips of it on YouTube at one point, maybe years ago, but it's probably almost impossible for it to ever predict a high rating for the holiday special if nobody else in the database actually predicts it high. Now, I probably got that wrong, but etc. Okay, so I am going to go. I'm going to put on my goodbye song. Everybody ask what this goodbye song is. Let's see if I can find it. At one point, it was on SoundCloud when I looked for Rainbow. And it was like, shoot, I just searched Rainbow, and then maybe I on SoundCloud, I think. Oh no, maybe it was Free Music Archive. I don't know. You know what, to be honest, I don't remember where I got it. I have to look it up. Okay, I'm gonna see if I can take some questions. Okay, hold on. I'm getting some comments here in the Patreon group. Nick writes, but you're in the set that's very influential, wrong numbers. You input them wrong, 1 and 2 are wrong. But I took myself out of the data set. So, but I inputted them wrong. Okay, yeah. I think there's been talk of a guest tutorial. Oh, video request 3.js. I would love to do a video tutorial on 3.js. I'm hoping to get my act together and have a lot of guest tutorials in June. So June is my most free month of the year where I'm working and not teaching. So I'm hoping to get a bunch of guest tutorials in here. If anybody has suggestions for somebody in the New York City area who would be great for a 3.js tutorial, just tweet me at Shiftman. I would love to do that. Nick, we'll work this out later. Okay. Oh, this doesn't do the pause anymore. Okay, can I do this? Yeah. Okay. Any other questions? I'll take a few more questions. We'll be back. I hope to be back next Friday. For anyone still watching, let me remind you to tune in next week to the ITP thesis presentations all week, live stream all day. I'll be in the audience. I don't know, maybe I can have, if you want to join and become a patron, patreon.com/codingtrain and join our Slack group. We could have a Slack chat during ITP thesis presentation and discuss all the thesis presentations. Cryptography guest lecture would be great. Socket programming in the snake game. I have a snake game tutorial and I have WebSockets tutorial. I did one for Agario and agar.io, and I did also a shared canvas drawing one. When will be the next live stream? So the problem with this, if you look at the schedule, thesis week, where's the schedule? Presentation schedule. So will be watching all of these presentations. Monday I have some meetings. I will be watching these from noon to, it ends at 4:30. Tuesday I'll be watching these from 10 a.m. to almost 6 o'clock. Wednesday from 10 a.m. to 6 o'clock. Thursday from 10. So I'm hoping that I'll have some time on Friday to do a live stream. So it will be next Friday. The thing is, we'll also have a show of student work. I wouldn't be surprised if I miss getting to do a live stream next week. But where am I in this particular syllabus? I am now, I would say, I think I would love to hear feedback from you guys as to whether, if I should do some more videos on this stuff or move straight to neural networks. Like, was that enough for this? Okay. Neat. I love neuroevolution. What does NEAT stand for again? But I love NEAT, which is using an evolutionary algorithm to evolve a neural network. Oh boy, I've got some demos of that. I'm going to do some video tutorials about that. That's coming. It's one of my favorite algorithms to work to use. Yeah, so everybody can watch all those presentations. I won't be live streaming them on my YouTube channel. There'll be a separate live stream. But just remember, I'll tweet it out. Just go to itp.nyu.edu/thesis. Multiplayer snake using sockets. Yes, I would get spiking neural networks. I have not. I'm not familiar with that term, spiking a neural network. So maybe somebody could fill me in. Oh, camera went off. Neuroevolution through augmenting topologies. Yes. Okay. When will this live stream be over? In 48 seconds. I hope you guys I hope today was good. It'll hopefully be useful. I think these are going to be very long videos. Mathieu, if we want to break them into smaller chunks, I could come back. Even tomorrow I might have like 20 minutes just to record some intros and outros, if that would help. Thanks, Sacrifice Productions. Will I do a Ruby on Rails tutorial? That's unlikely. Again, if anybody has suggestions for guests, you can you can tweet at them and tweet at me. I would love to have more guest tutorials. I'm trying to figure out a good mechanism to be able to pay people to come in here and do guest tutorials. And so again, I'm using some of the patron funds for that. I'm really trying to include a diverse set of voices in guest tutorials. So suggestions, especially women and people of color. I would love to have suggestions for people who can come and do video tutorials. Keep me posted. Okay. Will I ever do a Rubik's Cube code solver coding challenge? That sounds hard. Okay, I'm going to be gone in a second. Yes, there already is one, Kay Weekman. There is a guest suggestion tab already in the Rainbow Topics repository. I do have a plea, though. Here's a plea if you want to help. I really feel like I need a better system for organizing all of the source code that's with my video tutorials. And so if anybody wants to help with that, there is a GitHub issue thread about that. At some point, I might have the resources to hire somebody to build a website, but I would also be happy to do that as like a kind of community-based thing. So if you want to help me, even just figuring out like a better directory structure and just leaving it on GitHub, writing a better README. This README is like so old; it has nothing to do with my YouTube channel anymore. So I would love help with that. So maintaining GitHub repositories, potentially I could have, if I go to the codingtrain.com. I don't know if this isn't, there's a lot that could happen here. So if you're a web designer, GitHub person and want to contribute, I would certainly love your help. Okay. All right. There won't be a live stream tomorrow. Today is the live stream. And I will see you guys hopefully next week, next Friday. But if I don't, by the way, expect a surprise. I don't know if I'll, anyway. Come and watch the ITP thesis live stream, join the Patreon community, and participate in a chat during that live stream, and see you all soon. I'm leaving now. Need to say that to more than 300 people. Yeah, good point. So can you link the ITP? Somebody link the itp.nyu.edu/thesis. I don't know the URL for the stream yet. Oh no, it was in there. It just didn't show up yet. I think it might actually be itp.nyu.edu/live. Was that what it was? No, that's something else. Well, let's just find this right now. The presentation schedule, live stream. But this might change. So I would just go to itp.nyu/thesis and there'll be a link to this. But I know there's going to be like a 360 live stream and everything. But right now it's thesis audience.html. Okay, yeah, no, I might do. I have a new system where I can live stream from my phone, so that's where I was like, oh, maybe I'll do a surprise live stream just from my phone, wandering the hallways. But we'll see. I don't want to promise that. Okay, that might be just a bonus for the. I'm like, I don't know why I'm into like motivating people. So when I test new technologies, I often do like a private live stream just for people in the Patreon group. Maybe, I don't know why I'm really plugging this Patreon thing. It gives me such happiness when I see somebody join. I also would think I wonder if there's a way. Okay, I got to go. See you everybody later. Thank you for being here, and hopefully I'll see you next week. Subscribe, like, share this channel with other people to bring more people into the community. And more people that are here, the more time, and it helps me just have more time and resources to allocate to it. So I'll see you all later. I'm going to hit the stop now. Okay. I hit the stop recording.